It's nice to have you all back and not lost somewhere in the city of Vienna or in this building. Just yesterday I told some of the guests that we have some gravestones somewhere down, but we don't have graveyards there. We just tested the gravestones. So, some announcements to do today. We asked yesterday that you can vote for the best poster. The voting is open till lunchtime, and then after lunchtime we collect the votes together. And which we also want to say is not only the best poster, but also there's a best paper award, which we will give in the conclusions and in the closing session today. And which is also very important for the dinner. Some of you might travel from here to the place where we have the dinner, which is the Mayor City Hall of the city of Vienna. But you also find a plan on the website, how to reach there if you go to the hotel just before that. Yesterday we already had a very nice program with a different mix of practice session, scientific talks, and today's program will be about the same. So we have a very interesting mix of different talks which we saw all the kind of state in digital building permitting system. But the first talk will be a little bit different. It's our research track keynote session about applying psychology to digital building permit processes. I don't know if this counts for architects or more for the authorities, but we will see. Let's welcome Jacqueline Wheatcroft. Thank you.
Thank you. So yes, my name's Jacqueline Wheatcroft. I'm actually a forensic psychologist. So it's very interesting that I've come together with a few individuals in this particular arena, and I've been invited to give a talk today here. So thank you to the committee for inviting me. So as the introduction said, I'm going to talk a little bit about applying psychology to building permitting processes, and we will continue without further ado. So, as we can see here, there is an array of different factors that are relevant to building permitting processes, as Fouth showed in their paper in 2024. You can see that there's a whole different array, and apologies if you can't see it at the back, but there are too many to go through here today. But what we do know is that building permitting processes are very complex and pose particular challenges and many challenges to obtaining accurate outcomes. So a lot of my background is around looking at how to make things more accurate and increasing the relationship between how confident people are and how accurate they are, so that that correlation is a strong one. So what we can see is that we have things like regulations, relevant law, we have fragmented systems potentially, we have inconsistent applied or application of automation or automatic systems, people using different things, maybe even poor governance, and stakeholders, and even design factors. So there's a lot. I've just drawn on a few there from that array of that circle there. So there's a lot of things that are relevant. But I'm here today to talk about humans. So there's lots of digital stuff, and I know you're all interested in the digital stuff, but I'm here to talk about people. So in that, what do we know? I mean, I have 20 minutes. There's no way I'm going to cover all of the different things that, the human factors that are relevant. I'm going to give you a flavour. So people can fail to notice things. So they're influenced by the situation, their individual characteristics, which is also complex, and their perceptions. They can also fail to identify risk. And if they do notice something, then individuals might not necessarily perceive that as a risky thing. And even, whether it's even worthy of intervention or not. But there's other things that are relevant. So they might fail to take responsibility. In that, it's not their business. I don't want to get involved. It's not part of my role or my job role to do this. Sorry, I shout if I'm moving the mic and you can't hear me. Someone else will do it. And what we call that is a diffusion of responsibility, because it passes around and people can just pass over that responsibility to get the job done. There's also skills deficits to think about. So knowledge, particular types of skills that they might need, and how to act or make the best decision. Audience inhibition is also a factor. So we all know we don't want to be judged in a poor light. And this can also, drive the way that people respond to things. So fear of negative consequences is a big factor for people. Regardless of how they present, internally, it's problematic. And if they have a perception of low control in the situation, then they're much more likely to feel greater inhibition and, walk away from something. So these are things that matter. I think if we can think about people as theorists, so every day we test hypotheses as people. So what we do is we use mental structures to organise our knowledge, and these tend to fit around themes or topics. The process of that is quite complex, but basically what we do is we filter stimuli, information that we receive on a daily basis. And what we do in that process is we filter out information that doesn't accord with our schematic structures. The more that we filter out that information, the more resistant to change that structure becomes. Now, some of the disadvantages of that are that, we can maintain inaccurate beliefs. It distorts the evidence, which can lead to poor decision making. And that basically becomes a perseverant effect. So the schema, the structure around a particular topic becomes much more resistant. And it will stay that way, regardless of the evidence that's presented to it. So, for example, a jury member who needs to, decide an outcome in a legal process, everyone brings to a situation their own personal thoughts, beliefs, opinions. Regardless of the evidence presented, a particular individual may have a very strong schematic structure towards something. And so, regardless of that, they won't change their mind. Some of the advantages of having these schematic structures is that it's very cognitively efficient if we can do something very quickly. We'll decide to do X rather than Y. So there are some advantages to having these structures that make our day-to-day living less problematic. It also sort of removes some of the ambiguity in situations for us too. And it also resolves dissonance. So when we're concerned, we don't know which way to turn, we don't know what to do. Make a quick decision, and that resolves that dissonant feeling, that uncomfortable feeling. There's also things like scripts and schemas, and scripts that are routinized behavior. So I'm quite sure that everyone in this room gets up in the morning and does the same thing. Show of hands? Well, a few. It's not too bad. So we all have, these scripts that we adhere to. And we do those because they're comfortable to us and it's what we like to do. And we've developed those over years and years and years. And if that script becomes interfered with, then we feel less comfortable and we have to resolve it. So that's the sort of thing I'm talking about. So a script is a coherent sequence of events expected by the individual, involving them either as a participant or an observer. They're often unconscious scripts, so you get up in the morning and you go to the bathroom, or you clean your teeth, or you go down and make a cup of tea, or coffee. Yes, sorry, or coffee. And that's what makes you feel comfortable in the morning. But they're often unconscious because we do it, it's a part of our routine that we do every day. The problem with those is that if you're applying them in different contexts, then they can lead to risky decisions being made because they're made on incomplete or flawed information, potentially. The reality is that people don't actually assess risk as they draw on their interpretations. So I've mentioned about the scripts and the schemas and how they can become more resistant to change. And it relies on their interpretations, behaviours and actions. So we can see how in a organisational context these can also apply. Sorry, the floor's creaking a little bit as well. I'm moving around. So let's think about human processing and errors. We have active errors and we have latent errors. So active errors are things we know about. We don't need to worry about these so much. We know what they are, we can predict them, that something might happen. So if a forklift is on the warehouse floor and it's travelling around and it goes outside of the lane, then it could kill somebody. Very simple, we know about that. So that's about driver behaviour, etc. And we can plan for that. So we put down yellow borders so that the drivers can stay in that lane. So we're not too worried about those, even though accidents can happen. It's the latent errors that are problematic. So these are decisions or actions that lay dormant. They're potential things that can happen. And they only tend to become evident once they combine with an environmental or a triggering factor. And then they come to the surface. So basically they're present within the context of the individual and the environment. But it takes a couple of things to come together. So one thing I can think about is, an air crash or the decision-making process that takes place when pilots have to make a different decision about what's happening, and they have to go through a process. The situation is unusual for them. They don't know what's happening, and they have to go through a process to find out what to do, what action to take to avert a disaster. So, is it a form of risk-taking? Well, there's an example here on the slides of routinized everyday behaviour. So I've given a couple of examples already, but this is an actual example. My supervisor gets behind the machinery. I could stop it at any time and he could walk into it. I could have killed him 5 times this week alone. That's an actual quotation. So this may be thought of as risk-taking. But it's not if it's routinized behaviour. People don't see that as risky because it's something they do every day. Putting a guard on a machine or something like that. There's many accidents that happen because of this kind of routinized behaviour. So it's what happens every day. This is not risky to people. Of course, people will gather information. Sometimes they'll gather information before they make a decision, before, that filtering process, before they abandon that original course of action that they were going to take, that perseverance effect that I mentioned earlier. Especially when there's no clear schematic structure or course of action to define what they should do. What humans do is look to others for cues, how to behave, how to make decisions, and what to do. But in the absence of that, they will fall back on their schemas of their knowledge and what they know already. And that's what can lead to risky behaviour. One good example here is the King's Cross underground fire in London many years ago. I gave a talk, actually, a few years ago about this very incident to a health and safety executive in the UK. The problem with this, I'm not going to go into it in detail here, but it was an uncertain situation for people. So everywhere, the underground was full of smoke, people didn't know what to do. So what did? They did what they knew, what they felt safe doing. So they entered, where they entered the underground, that's where they wanted to leave, because they knew the route and they knew the way out. Actually, police officers were saying, we need you to leave by a different route. And many didn't. And that's what caused so many deaths in that particular fire. But it's because people have routinized behavior and their knowledge and understanding is affected. The way that they behave, the way that they make decisions is affected by, the fact that they have that information. And because they don't have any alternative view, they will fall back on, I'll nip to the toilet first, I'll call my wife, I'll tell her what's happening. I'm not going to follow those instructions because they could be wrong and I could die. So people didn't see that as a risky situation. They went along with what they knew. This is all then evidence of the strength of the scripts and the schemas that I'm talking about, and are all relevant. If they're relevant in everyday life, they're also relevant in organisational structures and the way that people approach their job roles and what they do. So it's clearly important then that groups and individuals faced with the task, like a building permitting process or other processes I'm going to mention soon, that they can make accurate and confident decisions, that when they are highly confident about something, a decision that they've taken, that they're actually right. That's what matters, that relationship between confidence and accuracy. So some of the research that I've done has actually used realistic decision-making scenarios that have demonstrated, these individual factors and environmental factors such as, I've done so many, but I can only give you a flavour today, such as task difficulty and risk. So the more complex something is, we would expect less accuracy. And I'm going to give you a couple of examples. What we know about the building permitting process, which isn't unique to other processes, is that it's operating in a complex environment. It's got human factors that have varying skills of knowledge, varying project typologies. I think that's very diverse. Very diverse. And then you've got multiple stakeholders who are involved in it. So I want to give you an example of a project that I've been involved in. So warships, military, defence. So this project was about air defence, and it was for the Defence Science Technology Laboratory in the UK, which is an arm of the Ministry of Defence. And we were looking at ship systems and part of the Integrated Survivability Programme, which is still running up until 2030. So some of the relevant issues for air defence operators is how do we optimise the operations room? So things like ways of working, the structures that are happening and how we can improve them. Command team information flows, so relevant to your area. Identifying bottlenecks and that excessive information that you get in that situation to try and find and enable focused interventions. Also, thinking about where are there repeated requests for things and why is that happening? And how does that influence or have an effect on the delays that happen in the processes? It's all around improving the overall tactical picture. So, thinking about low levels of automation and identifying errors and how we can make things more accurate. So for those of you who don't know, something I didn't know a lot about until I got involved in the project was that a ship's operation room is actually the focal point of the warship. It's where everything happens. It's where significant information and incoming tracks of information fuse together. And the personnel involved there have to deal with that information. And it could be that it's critical. And so they're working in a very complex, critical environment. And it's demanding too. So what we were looking at was measuring the accuracy, the confidence, the meta and cognitive abilities of air defence operators. I even got to visit the warship and go on the actual operations rooms. So that was really interesting. So what we did was we did things like taking quantitative measures, looking at some other measures that were subjective, but also objective measures as well. So just one aspect of this was building a peace enforcement scenario. 1 minute, okay. Peace enforcement scenario with subject matter experts, and you can see here that we were looking at a whole range of different factors, and that task load affected decision accuracy detrimentally. So I'll do my best to do 1 minute, but it might be 2. Okay, we'll just get that agreement now. So another area that I've been involved in is changing the law in the UK around how witnesses are questioned in court. And that's all come about through looking at how different question types affect people's accuracy and confidence. So again, a critical context in which these things happen. So the backdrop to that was that despite the use of leading questions, the law had not actually defined a leading question. So what I went on to do with colleagues in Australia and other Commonwealth countries was that we defined the leading question for use in court. So what I pride myself on being able to do with the work that I do is to carry out the research, but also be able to see or have the vision of how to change the context, how to apply those results and translate that research into practice. And that's what we did with this project, was we were able to change the law in England and Wales, and that is no mean feat. So for 600 years, barristers had been asking questions in a particular way. And through the build-up and the body of the research, we were able to change how that happened. And that's relatively recent, from 2016 onwards. Just a couple of other examples of where I've been involved with the AEC industry. So looking at collaborative culture, where, obviously people have to collaborate in project meetings and things like that. So we were looking at that, looking at project-to-project comparisons. So some of the factors that emerged from that were client knowledge, existing relationships between teams, stronger informal collaboration that already took place or already existed, a decentralized leadership style, so top-down doesn't necessarily work very well, people don't respond well to that, so it's all about an inclusive, collaborative environment, and also an adequate monetary incentive as well. Okay, Judith. Project factors as well that we found was that, more changes, more uncertainty, more assumptions, all led to, a lowered effect of collaboration. And we also took some individual factors which were around, the nature of people, and that agreeableness was one of the things that came out as really important. So if we had collective agreeableness in the nature of the individuals who were part of that culture, or part of a team, then we were able to obtain a greater collaborative culture. Nearly there. Another thing that we did was common biases in industry as well. So there's a couple of papers there that are quite interesting that I was involved in, as I was part of the supervisory team for that student, that PhD student. So this is my final slide. I think everybody will be pleased to know, especially at the front here. Just to wrap up then, I just wanted to give you a flavour, because we can't ignore the human factor. The human factor is where things can go wrong. You know, I stand here as a human. We all know we can make really poor decisions for a variety of reasons. So, just to wrap up then, it's a challenging context. Processes are complex. And in terms of the building permitting process, it aligns itself very well with many, many other contexts. It's the same kind of things that are happening, even though you've got experts. So thinking about the MOD project, these people were trained, highly trained military defence people, but they were still poorer than some other people that we put them against in terms of making their decisions. So human factors are important. Human thinking and reasoning and the processes, they're flawed, fundamentally, particularly when in the face of lack of information or uncertainty. These are key factors. Psychological theories can enhance what we understand and what we know about things, but we can also set up then quasi-experimental, quantitative experiments and qualitative methodologies as well, so that we have an evidence base for change or adaptation. And I think that's what's important. So it adds to interdisciplinary research, so that we can take account of those human factors. So finally, I'd like to say that although we're all people, we know we're all flawed under certain circumstances, under certain conditions. We're not perfect. But what we can do is investigate and account for when errors might be made. So it's really important to include human factors in anything that you're doing or thinking about in the future where processes require decisions to be made. Thank you for listening.
Good morning, everyone. Thank you, Jacqueline, for a great keynote. My name is Farzad Jalaei from National Research Council, Canada. I'm glad to be here, and I'm chairing the first research session today on technological and procedural system. We have we have 5 research presentation today. As I was told, like, we are behind the schedule. We almost have 10 minutes for each presentation and maximum 1 question for each presentation, probably. And I can see we are heavily, our presentations are about the AI and application of AI on building permitting. I would like to invite the first presenter, and the topic is Retrieval of Digital Regulations using Neuro-Symbolic AI with GraphRAG. Alex Donkers. Yep, thank you.
Yeah, imagine that you're an architect and that you want to design a building like this, and that you want to know what the maximum fire compartment size of this building is. And imagine a system that could perfectly answer that. For such a system to work, it needs to know what a fire compartment means, what building we're in and what size means. And for me to understand this answer, I need to know what a brandabschnitt is and what the OIB2 standard is and what a standard anyway means in Austria. And I would probably also like to know how brandabschnitt relates to brandcompartiment, which is the term that I use in my country, and how it relates to how we model in BIM. My name is Alex Donkers. I'm a postdoc in Eindhoven University of Technology, and together with Ekaterina Petrova, we did this work on retrieval of digital regulations, where we're basically trying to tackle this challenge of navigating through regulations, which is super difficult. Regulations are highly complex. Here's an excerpt of the Lithuanian regulations. They're super voluminous, jargon heavy and ambiguous. Regulations vary wildly across countries. These are the Belgian regulations. They have all these figures in there. Hardly any structure in these regulations. And the difficulty of these difficult structures makes that it's hard for non-experts to, in the early design stage, find the relevant rules for a specific project, which leads to misinterpretation and costly redesigns. So we basically followed your advice, and what we're trying to do is make these regulations machine readable, interpretable, and standardized so that the access to these regulations and the information in these regulatory documents is easier for non-experts. And we do this using a 4-step methodology. First, we try to structure these documents as RDF graphs, or linked data graphs. Then we enrich them using Neuro-Symbolic AI methods. We use a GraphRAG method to enable retrieval, and we wrap everything inside a chatbot interface so that regular people can use these technologies. So first things first, structuring as an RDF graph, we developed this relatively simple FRO ontology that you're likely not be able to read. It's online. It basically describes that an authority for a certain jurisdiction issues legal documents, and these legal documents contain parts such as a title, a chapter, a paragraph, an article, etc., etc. And for each of these parts, we are able to represent metadata related to these parts. And using that ontology, we're able to convert these documents into graphs, such as this one, where we can state that parts of these documents are articles and they have statements, and statements contain or consist of a couple of items, and these items have a textual representation in the document. Which is nice because now we know that this individual sentence is what I call an item, but I still don't know whether it's about fire compartments or not. So the second part of this methodology tries to enrich this triple with domain knowledge. So we take a domain ontology, in this case a fire safety ontology, and we asked experts to select topics from this ontology that are relevant for querying. Then from the graph that we just created, we query all these orange sentences basically, and then we run a multi-analyte-based classification algorithm to match the topics from the ontology, such as fire compartment, with these sentences. And if it gives a topic with a very high similarity score, we would enrich the graph with this new triple about fire compartments. So now we know that this sentence is about fire compartments, and it's explicit in the graph. Which you can query with a Sparkle query, but I don't expect the architect to know Sparkle. What I want is the architect to be able to just post a question and get information. So for that we use GraphRAG. We basically developed a multi-shot LLM prompt where we inserted this FRO ontology and the domain ontologies and example Q&A sets. This is what such an example Q&A set looks like. So it's basically questions that the architect could ask and how I would translate that manually into a Sparkle query. And if we give more and more of these example Q&A sets, the LLM starts to understand how to translate natural language into Sparkle. And then using that prompt, the LLMs were able to generate Sparkle queries that were functional and that were able to retrieve data from the graph. Then finally, we hid all of the technology behind the user interface. So what this chatbot does is it basically shoots this Sparkle query against a graph database and then returns information from that graph database, reformats it so that humans can read it, and prints it in a chatbot interface. So this is what that chatbot looks like. FireBIM always warmly welcomes you. And then the architect can ask a question, for example, give me all the rules about fire compartments and residential functions and their text in English. And then that chatbot would translate that query into a Sparkle query, shoots it against the graph database and responds with this answer. So this answer is not generated by AI, it's the actual data from the graph database. So it's not a generative AI thing, it's something that we can control. You can also click on this Sparkle button to see what Sparkle query it generated to check whether it actually returned the right answer. We faced a couple of difficulties. Sometimes sentences were simply incorrectly converted to Sparkle queries. For example, in this case, give me the Dutch text of all rules about industrial functions or healthcare functions, which has an or statement. It generated a Sparkle query, which looks like a nice Sparkle query, but this is actually an AND statement, so it required industrial and healthcare functions. So how we tried to solve that was by adding more Q&A examples in the LLM prompt, where we try to, for very specific logical operators, try to explain to the LLM how they should be translated. In this case, an OR function should be translated to a union in a Sparkle query, and once we gave that, it understood, and it could also create these queries. There's still many open questions. We enriched the graph with these tags, so something is about the fire compartment, which was on item level, but does that mean that this is a transitive property and that the entire chapter is also about fire compartments? We don't yet know. Currently, the chatbot is just a retrieval thing, so you can ask something and it gives you back regulations, but there's no conversational opportunity afterwards, while most of your LLMs typically enable conversations. So we're not sure whether we want this, yes or no, whether we need this. And we had a lot of trust issues. I work with a lot of practitioners, and they hardly distrust anything that is AI, especially in the legal domain. We need mechanisms where humans can basically validate every one of these intermediate steps. And that's where I like to conclude. So everything was built in JavaScript, but we kind of recreated the tool in Python so that you can also check it. So it says it's this Jupyter notebook code, so if you want to rebuild or play with it, then please go ahead. And I'm happy to answer questions.
Thank you, Alex. Right on time. We are open for one question, probably. Yeah.
You are trying to get information out of the regulations. Did you try also to translate the regulations in machine-readable text with AI?
Yeah, good question. So what I currently presented was, I basically convert the structure of the document in an RDF graph, but as you've seen, the end of the graph is still a natural language sentence, right? So in this paper we did not. In previous works we did, and there's multiple methods. We used NLP-based methods and even regex-like methods. And we're currently indeed exploring hybrid AI and symbolic representations. Our idea is to convert rules to shekel shapes that we can then also query using this system, and corresponding IDS so that you can check the information requirements in a BIM model.
Thank you. I assume that there is no more question. Thank you, Alex. Thanks so much. Okay. The second presentation is Aurica Pötz on automating the assignment step in the building permit process.
Hi everyone, my name is Aurica and I would like to present you the results of my master thesis, which was supervised by Judith, Joaquin and Sebastian. And my introduction can be very short because you know all about the problems, and we heard yesterday about the staff shortage, the long times, the high workload, and we need ideas to optimize it, and heard yesterday a lot of ideas and solutions about it. And my way was I decided to pursue on ontologies. Here. And especially the OBPA, it's an ontology for building permit authorities. And we have seen it in Judith's presentation yesterday. And I focused on the assignment step here. So which building official gets which building application for the review process later, and this is important for the efficiency and the quality of the review process. And I had the OBPA was developed for the German context and validated for it, and my question was how it will look like for an international context, how the process looks like in other countries, and how we can adapt it and extend our OBPA. And therefore I made this two-stage development and started with collecting data in Australia with a survey, and later analyzed it, and I've analyzed data from European interviews and used these informations to extend the OBPA. Here you can see the results from the European analysis. The most time we have a human supervisor decision, and less times an automated non-machine decision. That means that there is something like a stack where all the applications are in, and when you need some to review, then you grab one. So it's not a supervisor who made the decision, and it's a self-ongoing process. And even less than an automated machine decision, which will be the way where we want to go. And for Australia, I don't have such a chart because they have all human decisions. Then on the second step, I have a closer look on which are the criteria they will be used for this decision. And as you can see here, there are sometimes chronological decisions. The most parts are the territorial criteria to decide. And then in the yellow parts there you have either the content-based criteria in general, or the type of building which is important, sometimes the experience, type of procedure and so on. And in the light blue there are some additional criteria which I find in the transcripts. And so yeah, the important part here is the workload each building official has. And for Australia, unfortunately, it's not exactly the same clusters, because I've made the survey first and later the transcription analysis. But yeah, it's the same topics, like the chronological, territorial, then content-based, and some additional ones. And you can see that there are many different criteria which are used. And the surprising part for me was that it's not country related, so it's only authority based, and it's not that one country has one criteria and another country has different other ones. So it's mostly that every authority decide for itself which criteria they will use. And that's why I don't have the ontology extended for each country. So I decide to make it one big ontology with all the criteria. And so then every authority can later choose which of the rules and the criteria they want to use for themselves. And as an example, here's the first one for the chronological assignment. This is an extract from the whole ontology, and where you can see I've added the building application and building application date and the has date, the two properties, and then wrote a Sparkle query, which can be later used in the rules. Okay, so then. Yeah, then finally, now we have this analyzed data of 14 countries. We found that we have mainly human supervisor decisions and a multitude of different criteria, which are authority-based. then developed this basis OPPA with all the different criteria inside. And yeah, the advantage is that the OBPA is a standardized semantic web ontology and can generate it in different languages, so it can be used in different countries. And there are only some countries, with 14 countries. This is a limited selection, so there will be much more criteria in other authorities, but it gives a good overview, and it's a beginning. And so the next step on the outlook is that the future can deal with creating a user interface for it, integrating it into the existing software landscape, and testing it in practice and building authorities to validate.
Thank you, Aurica. We are open for questions. Any question from audience? Oh.
Hi, thanks, cool work. Good that this is getting extended. I was wondering, you propose one extension for all these countries, right?
Yes.
So did you check whether, for example, how one country wants to report on the issue date, what data type they use? Is that the same across these countries? And did you check whether they had difficulties with using that, like, I don't know, one harmonized European system?
Yes, okay, for this chronological, there can be different times when this step will be ongoing, because sometimes there is this formal review before and sometimes not. This can be different, but I think that this should be recognized in the rules. So somewhere in the beginning, when you start with the ontology, you have to set which rules you want to have and to use, and then this should be there somehow integrated there.
Thank you. And I have one final question, like probably very generic question. In your surveys, how Australian building permit process is close to be kind of like a BIM compliant or relevant to, BIM-based process? Did you touch on that part or ask questions on the surveys that you have done?
No, I have the survey only on this assignment part, but I was in Australia and I was one time in a city council and heard something of this, and they are working on it, like we're all doing.
Yeah, thanks so much. Thank you, Aurica. Okay, and we are right on time. And the third presentation is LLM-based translation of tables to support automated compliance checking. And we have Stefan here.
Okay. Hello, my name is Stefan Fuchs. I am a postdoctoral researcher at TU Munich. You see, my name is not written there. I'm presenting on behalf of Robert Amor and Yuxian Zhang, who unfortunately couldn't make it here. But I have collaborated with Yuxian, and Robert Amor was my PhD supervisor, so I'm happy to take over for them. So the topic is about machine-readable representations and how do we transform tables into such representations using LLMs. The motivation is that automated compliance checking is a central part of the digital building permit, and the standard way of addressing that is by going through machine-readable or better machine-executable representations. But there are numerous tables, figures, and other things in regulations which are typically not looked at when we are speaking about the machine-readable representations. And on the other hand, we have large language models which are really good in understanding such formats as well. If we are looking at the related work, we see again the same picture, that most papers are looking directly at the clause level. How do we translate clauses into different machine-readable representations, maybe first-order logic, legal rule-ML, Sparkle, or directly into a programming language. On the other hand, for table data, there is less research out there, and what is out there using LLMs, that's rather towards, okay, how can we do question answering on table data, but for that we directly move it into a SQL database, for example, and then have the LLM write queries. But the question is there, how do we get those tables into the database? So what the problem that they were targeting is how do we know how the tables are structured? What is the meaning between the different cells? We don't even know necessarily what is the header, because the first column could, the first row could be the header could be in the first column, it could be multiple rows that are the header, so the tables get really complex in there. And to address that, they proposed a multi-step LLM-based framework or a method to extract the semantics from tabular data. Here you see an overview of the method. They started with regulations in PDF format using OCR, standard OCR tools, which did not go 100%, so they still had to have a human involvement to fix and make sure the OCR step was correct, mainly because that's not the main focus of the paper, and to have a solid foundation. Then, given the data, they were looking at three types of data. On the one hand, the tables themselves, but also the table captions and the clauses, because both of them could have very relevant information on the tables, which needs to be included. And then coming to the LLM-based part, they split the understanding of the tables into multiple steps. First, determining what are the headers, then determining what are the attributes, what is the object that should be checked or that is referred to, and finally transforming everything into an XML-based format. Going through that process step by step, the first part was looking at what is the header. For doing that, they were giving in the first row, the first column of the table data into the LLM, and making the LLM reason on which of those two contains the header data. The next step was then looking at the supporting information, the clauses, the captions, and can we extract the referred object and the attributes. For example, if some table is about spaces, maybe space classifications, then we would try to get already, okay, the space is the object, the type of use, the usage classification is the attribute. If the information is not in there, then we would still try to look also at the header, seeing is the attribute somewhere in the header, and everything that's not the attribute, we would say will be a condition that's put on the data. And in the next step, they were looking at the different cells and trying to make the relationship from each cell to the header data. They had three types of predefined relationships: key values, same, and none. So the key value would be if the values coming in the rows are kind of an instantiation of whatever is in the header. In this example, the calculation method, you would have a key value relationship to the quasi-static method and the dynamic method. But you also see in the calculation method in the second row, it's still the calculation method. That would be what is the same relationship. And the values, the 2.3, they would be as none because they are directly referring to the object attribute, which value they should have. Given all of that information, they then transformed it into XML format. The object that we extracted would be the root element, and the attributes, including the value, would go as the attribute of that, as the property of that element. And then finally, all of the conditions that are additionally in the table when the specific values or the specific attributes should have that value would come then as child objects. They tested that on 200 tables in Chinese design codes for hydraulic structures. The dataset is available there, and evaluated it with different metrics: tree edit distance, Levenstein distance, and 2 LLM-based metrics. And coming to the results, you see the results, the tree edit distance lies around 0.73, so there's still room for improvement. It also shows that the task is not very simple, so we should put more effort into that understanding of those tables. And we also see that the DeepSeek performed better than the GPT models, most likely because the dataset was in Chinese. So the DeepSeek has more Chinese training data in them. So it might look different in, for example, English data. Looking at the error analysis, there are many different error cases. Sometimes the LLM didn't recognize the correct relationship between the headers and the cells. Sometimes it's mostly because the more complex structures, when we come to cases like here where we have the first 3 rows which consist as the header, then that's getting very complex. And sometimes also the LLM just made up new rows which were not actually in the table, which is very problematic. And that would already bring me to the conclusion. So what we showed is how we can use LLMs in a multi-step process for translating tables into a machine-readable format. And that was tested on Chinese codes, but it would be useful to also test that on tables of other countries, and also seeing if those structural assumptions that were made in the paper also apply to other building codes and other countries' codes. Thank you very much. And if you have any questions, I try to have simple questions covered, but...
Open for questions.
Thanks, Stefan. That was great. In Canada, we're embarking on a similar challenge of trying to digitalize our tables. Our starting point is actually we have an XML format already, but it's really just simply to render the tables in a PDF or HTML format. I just wanted to clarify: was the LLM used to apply both the attributes and the conditions, or was that in part a manual step from the extraction or a software step?
I think that would be more like the follow-up steps. In this case, it was really just figuring out the relationships between the headers and the separate cells. And the application of those tables for the actual checks was not covered.
Okay, thanks.
Thank you for the presentation. So did you consider letting the large language model do a final pass of the table and the original to see if, identifying where they added an extra column, for example?
I don't know if they consider that. I think it would make sense to use the LLM as a judge and more having that code process in a loop, but it was not considered.
Thank you.
We can have one more question if there is no question.
Hiya, yeah, thank you. I've just noticed in some of the presentations the looking at the similarity score, I think it'd be interesting. I'm not saying you would know this because it's not your paper, but it's interesting to see how the similarity score is defined, and therefore that then feeds into, what comes after. So I just thought I'd make that general comment about similarity scores because they may differ across different projects.
Yes, it also depends on how they are calculated, usually the similarity scores are based on some embedding model, and then always it depends on how that model was trained. Was it trained also on tabular data? Because otherwise, if in this case, if the context is missing, they might do worse and it might be less similar. So yeah, I think that's an important consideration that should be included.
Thanks so much, Stefan. No question? Thank you. Okay. And the next presentation is actually my colleague Arash from NRC on integration of BIM and AI for digital code compliance in North American context. Before inviting Arash, I give a brief introduction on actually like a program that we started in Canada that is like the R&D program that's called Construction Sector Digitalization and Productivity. It's under the larger platform that we started in 2022 on decarbonizing the construction sector at scale. And it has like a partially kind of related to revitalizing the national model codes and Canadian Construction Material Center and national master specification to make it machine readable. And on the other side, we as Construction Sector Digitalization and Productivity R&D program trying to support the industry and also the federal government entities in terms of adopting this language and also trying to adopt the new technologies like digitalization of construction processes and the modern methods of construction that is like adopted in the with the industry in larger and national scale. We started like with frameworking the whole concept of how to make it machine readable, digitalized, BIM compliant, and moving towards the building permit processes. And we have published almost a year ago the big, larger framework. Actually, this is presented in Building Smart International Summit in Singapore last March. And also, like we have announced this many times in different occasions. And we are kind of like at the parallelly, we are starting doing R&D practices and discover more how we can kind of like catch up with the current progresses that we are witnessing in Europe and the other countries. And this is kind of like an ongoing process until year 2030, which we are bringing over the new revitalized national model codes with including the low carbon and performance-based language, as well as making it digitalized and BIM compliant. I'm inviting Arash to give the presentation on this topic. Thank you.
Thank you, Farzad. Hello, everyone. My name is Arash. Thanks, Farzad, for the introduction. So I'm research officer at National Research Council, and today I will be presenting our research work with my colleagues on the topic of integration of BIM and AI for code compliance and checking in the North American context. So at NRC, we are maintaining a couple of codes, including the building, plumbing, energy, and fire. We basically maintain the codes, but we do not have the authority, or we are not the enforcing agency on that. So basically this is brought down to provincial and municipal level. So those are the ones basically would enforce the codes, but we do maintain that, and we are in the progress of transitioning from to performance code from the prescriptive codes that we are having at present. So to begin with this investigation, we started at looking at the other projects within Europe and states in particular in comparison with Canada. So we basically started with the traditional code compliance checking, and then we investigated some of the European projects in particular occurred, and I think so most of our work is right now aligned with adopting that to our national codes. In addition to that, we have also looked at the existing projects that were carried out within North America that would be within research arms of Canada and states. So basically we have looked at both sides of the approaches that are existing, and we are basically trying to bridge the gap in terms of what our codes requires. We do have a bit of challenge. The main gaps are on scalability of our approach that needs, because Canadian codes is a bit large in comparing with other codes that are existing. We do have interoperability issues. We have been trying to transition to XML codes, and we are trying to manage that through the content management system that we are having to move towards machine-readable formats. And also we have, basically the Canadian codes is in both in English and French, so we do have this multiple nature of language of codes that we have in our system. So the basic stance of how the code compliance basically looks like within Canada is very similar to other places where applicants and inspectors would be having the communication, with the difference that the codes basically comes from, the building code revisions come from NRC, and we do have additive nature of work from new requirements coming from provinces and municipalities that are added. So basically this adds a bit of complexity to the approval process, which increases the back and forth loop between the applicants and the inspectors. So the methodology that right now we are investigating is basically we have adopted the Accord framework. We are enriching that a bit with the LLM work that was really interesting for me to see today. So it seems that works are being aligned on the both sides. So the transition is taking place. So as I mentioned, we do have our code structure right now in XML. We made that transition. We are trying to have consultations with other Accord project involve, I would say, consultants who are basically helping us to apply race taggings to our codes. And also in terms of quality assurance, we still keep the human factor, so we go back with our code experts to make sure that the race taggings are in place. So we are transitioning and we are investigating how we can have both LLM approach to what right now we are having with race, but in terms of rule formalization, that's again, we have taken the ontological approach and we are trying to formalize the rules in BCRL. And so basically we do have that touch. We are trying to maintain the compatibility with the existing words, and also we are adding the standardized tagging. So we are trying to, we have recently adopted ISO 19650. We are trying to maintain our approaches with BIM in mind. And in that sense, our ontology is supposed to support both BIM as in terms of IFC and the openBIM standards. So basically, the applicants would be transitioning from the PDF submittals in the future state to the BIM submittals, and then automated code compliance would be done through the rule formalization that would be occurring, and the results would be basically the fail-pass sort of results for reporting. So having that complexity within our code, so we do have 3 layers basically where it comes from: the applicants, reviewer, and the authorities having jurisdiction. Basically, those are the ones enforcing the code. So we do need to take this, I would say, 3-tier approach that we need to look at the requirements that are on the model submission. So the applicants needs to move from the manual approaches to digitalize, and then having the reviewer aspect, the inspectors basically moving to code compliance, the automated code compliance that we are working in. And also the third tier would be authorities. So basically we are moving towards digitalization for bringing out those tools and open standards that they can enforce for code compliance checks within their information management systems. So for case study, we have looked at the housing and housing books that we are having. It's part 9 in particular, where we are looking at the housing for our case studies to see the relevancy of the methodology that was briefly discussed. The case part 9 of MBC codes is basically friendly for SMEs because it is descriptive in nature. It does have, it basically provides all the information that smaller entities require for implementing their design and build information. So within RACE, we basically try to take a couple of clauses from MBC Part 9, and then we applied those RACE tagging that was adopted from the Accord framework with the help of our consultants. And this was in tandem. Basically, we had this training session with them, and we tried to do this ourselves at NRC. And so we took 10 clauses to check if MBC, basically the Part 9 is compatible with the method, and we had basically 80% encoded accuracy without any human intervention. So most of our experts were aligned with what this method could bring to moving towards more automated code compliance checking. So again, one of the key challenges that we are having is we do have a problem with cross-referencing between our codes. We need to take into consideration those challenges. Also the table, I would say the challenge of table is similar across, and we do have it with our codes as well. So those needs to be addressed, but the initial findings are that the AI assistance and BIM frameworks can be applied to our code as it states from before even moving to performance codes. So right now we will be trying to investigate that further. And so the future step we are having right now is we are expanding on the RACE. We are taking more clauses and other texts that we are having. Also, we are trying to have this in-house AI tools for that are open source in nature. We would like to basically provide this to the authorities so that they can experiment and see the applicability to their clauses as well that they would be adding. And as Farzad mentioned, we would be basically transitioning to this NRC digital construction platform, which would be open source and interoperable, that basically supports future tech that we are envisioning in terms of BIM submittals and AI assistance. And that's the roadmap towards our standardized digital permitting pathway right now. Thank you, everyone.
We are open for questions.
Yeah. Are you, very interesting, are you going to apply AI and natural language processing to do the RAISE markup so it can be reviewed by humans, or are you going to use AI and NLP to go straight to computer-readable rules?
Thanks, Nick, for that. Actually, we are exploring both the possibilities, but at the present, we would like to see how AI assistance would help us with the RAISE application. So that's something we are investigating.
Yes, thank you. I would like to ask you, did you search also this kind of legislation about the use of this securities about the public data? this kind of legislation part that is telling you that how you should handle the public data, and who could be the person that is access to this kind of information, this sensitive information, for example? Or did you study only for the building permit needs, the Building Act and others that is giving the guidance for the designing and safety and others? That would be interesting.
Thanks for the question. Actually, I would say we had this discussion with Farzad, and the security aspect, the governance is a part that we are looking at. Actively, I wouldn't say we have made any progress much there, but we are investigating how NRC could play a role in terms of holding the data, so within our platforms, and providing access to the OGDs and eventually to municipalities and provinces that could basically we work as a custodian of the data that would be coming from the applicants.
Yeah. At this point, I can say NRC is kind of a trusted party in terms of, like, in all government departments, in terms of holding the data, storing data, maintaining data, and we have kind of like a business model dealing with the other government departments who are owning the assets mainly and doing like these practices, like Department of National Defense, Public Services and Procurement Canada, or Infrastructure Canada. All are kind of like a trusted on National Research Council to move forward with this kind of like a developing common data environment and sharing data, providing access based on following their security rules and protocols, I can say. And we are kind of like trying to build this platform as a sample and kind of like a model for the, like provinces who are having like their own provincial codes, and also later on taking it to the municipalities or project level to kind of like use this openBIM or OpenShell type platform and kind of following this pathway, this harmonized pathway. And that would be also like a good example of being able to kind of like different platforms can communicate to each other and like in interoperable way.
Yep. And big shout out to David Minicola, who is helping us with this all efforts. I think
Dave, our colleague, is
he's
also
a key
like
figure
here.
in figuring out this entire thing.
Actually, the superstar like behind the all these activities. Okay, so any other question? We are still on time. I never used that 1 minute remaining badge still. Yeah, we can move to the last presentation for this session. Is thank you, Arash. Thanks so much. The last but not least is data continuity between BIM and GIS for seamless integration of outdoor spaces into digital twins, a case study in Austria. Daniel Pfeiffer and Morten Loës.
Thank you very much. My name is Morten Loës. I'm head of research and development at the WeBuild company, a subsidiary of the Vienna airport. And we are dealing with the GIS and BIM agenda of the airport, but also for external clients. So BIM and GIS, gapping this bridge is one of my favorite topics, and this is what this project is about and the presentation we're going to give.
Hello everyone, my name is Daniel Pfeiffer and I'm doing my PhD here at TU Wien in the research department for digital building processes. Our presentation today is based on our research project AMAZE 2.0, and let me start with a simple thought. Our research project is completely unnecessary if two conditions were always true. First condition, everyone took climate change and rising temperatures seriously. And the second, if every contractor reliably fulfills the obligations described in the building permit. But since we do not live in this perfect world, cities are facing growing pressure. On this slide, we see the specific cooling requirements for homes and offices in Austria for the year 2050. And I think it perfectly demonstrates that urban areas are facing growing problems with heat and heat waves. But it also shows the need for green spaces in urban areas for their cooling effects and for better air. We know this, but even with knowing this, cities still lack the tools, the data, and often the awareness to protect and manage their green spaces. If there are requirements, they are often inconsistently enforced. And cities often lack tools to verify approved outdoor spaces. For example, planting certain amount of trees, or keeping a certain area unsealed. This lack of verifiability becomes a major challenge. And if this is not enough already, there are different stakeholders, such as planners, contractors, property owners, and authorities, all trying to pursue different goals. So to align everyone around the same goal for environmental goals, we need transparent digital tools. And this is exactly where MAZE 2.0 bridges the gap between what is planned, what is built, and what cities actually need.
So let me quickly walk you through the intended process. Imagine an asset owner, could be a private person, a company, whoever, is intending to build something, a house, a building, a construction, whatever. And of course they have a planner to execute this or to set up the design. And they are using digital tools. They are using the building information modeling methodology. But what they need to start is reliable data on their asset. And this must be trusted by both the authorities and the owners. So right now, this is most oftenly done by land surveyors, but could also be stored in a central data storage. In our ideal world, this data can be retrieved digitally through APIs and can be then transformed from the GIS to the BIM authoring tool. Of course, we are designing and publishing in IFC. The building or the city authority will then be able to use their digital tools to compare the applicant model with the regulations and building codes digitally and of course automated. And when it complies with the rules, the building permit will be issued to the asset owner. This can of course come with requirements such as a specific amount of trees that need to be planted, or the degree of soil sealed or unsealed, and then this will be executed by a construction company. During the construction, the building has to be, of course, maintained. So we gain at the end an as-built model that will be reissued into the central data storage, into the digital twin of the city. But that's it. And after that, we have no clue about the whole setup of the city. Of course, you can walk around and try to measure what has been done, but this is a lot of work and this is a lot of costs that come to the city authorities. So what they do, and the city we are working with is the city of Klagenfurt. They have an annual flight to survey the city with remote sensing using digital channels like RGB, near infrared, and LiDAR. And they get a clear picture of what is actually happening about in their city and what is actually at hand. So we can use this data to compare it to the permitted models. And we can run it through an analysis and find out whether something needs to be done. And then we can issue notifications to the owners and tell them to redo something, plant new trees, or unseal the parking lot they built even without a permit. So this is the ideal process that needs to be fulfilled if we want to automatically detect changes in the city and compliance to the building permits. Of course, this can only be done with data continuity. We need standards, we need processes, we need the tools, but we have them, and we can do this if regulations would be fitting to it. So what we also used, of course, was AI and neural networks to harvest the data we got from the aerial, from the remote sensing, to create discrete objects. So from the pictures, from the images, from the point clouds, we could derive automatically or partly automated the discrete objects that read like trees, sealed or unsealed areas or partly sealed areas, houses, streets, and the like. And this is the base for automatic change detection and for the automatic comparison between the permitted and the actually built stuff.
To make this work, obviously we need GIS-BIM interaction, and we heard a lot about of this in the last 2 days. And basically we are trying to bring together two worlds that were never meant to work together, and we faced exactly the challenges that were already mentioned. For once, we are facing different coordinate systems. In the BIM world, we do usually have local Cartesian coordinates, and in the GIS world, we use global or projected reference systems. And these reference systems often introduce us to real-world distortions since the world is curved. And if that is not enough, we also face different scales. Usually in the BIM world, we do face one building at a time with millimeter precision. And in the GIS world, we are more interested about regional spaces and spatial context. So bringing those two scales together requires fundamental understanding of both worlds. Another challenge are the data formats themselves. In the GIS world, we do have a lot of formats, for example, raster or vector data. And in the BIM world, we are usually having standards, for example, IFC. And to enforce interoperability, we do not only need fundamental understanding, we need careful file translation. And the last point I want to mention is the awareness of the real world. GIS forces us to think about the real world, not the ideal model we have in BIM. So we need correct georeferencing to bring the model into the real world and build it on the real ground. So what's next for us? Since we have a functioning prototype, the next logical step is to introduce it to real authority processes. And we do that together with the city of Klagenfurt to see if our workflow works under practical conditions. But at the same time, we are in desperate need of policy actions. Political decision makers need to understand that we do have everything we do have the working tools right now. So everything we need for a greener future are policies supporting that. We would love to go into more detail about our workflow, but we are limited by time. So if you have any questions, feel free to ask us now or in the break. Thank you.
Thanks for a great presentation. We can take 1-2 questions before, I know like people want to go on a break, but yeah.
Hi. So I saw that you were running automated segmentation of the remote sensing results, satellite imagery, and so on. So you were using like a grassroots developed mechanism, an algorithm to detect the different categories. And if yes, did you take a look at some other available libraries like Segment Anything and so on?
Shall I answer? Yeah. We have a custom-built AI by Fraunhofer Institute that detects the different soiling categories that we defined, because we found in literature they usually differentiate between completely sealed and not sealed, but we wanted to make a more specialized categories. So they trained on an AI model. I'm sorry, I don't know the name right now, but we then used these labeled areas and feed it into the FME workbench to moreover create a whole system that operates together. This is our workflow, and it's working pretty good.
Okay. Thank you.
And any other questions?
Hi, from here. Thank you for this interesting presentation, and I'm happy to see that there is geo and BIM approach into digital building permits, but in broader perspective in digital twin. But my question is focusing on two things. How do you make sure to convert your minimum data requirements that are needed from the BIM to GIS, or also you do that seamless integration in which approach? And the second thing is, how do you make sure that you have a level of detail that is high for the surrounding buildings of the BIM model, so that you can also make sure to, do you do any collection, data collection, LiDAR, drone, or is this only the data that you collect? Thank you.
Yeah, so we are working on, in this project specifically, on the outdoor spaces. So the BIM model is, the building itself is not of a big interest to us. We just need the footprint, we need the sealed areas, and we need the outdoor spaces that may be divided into sealed, partly sealed or partially sealed, and unsealed areas. So the data requirement or information requirement is quite low. It's not that we need any insight into the construction. So we do not need to derive or kind of reduce the BIM model, because in this project we didn't go into depth into the construction.
This is probably going to be a Maze 3.0.
Perfect. So yeah, thank you, Daniel and John Morten.
Hello, hello, hello. So, it's wonderful to see all this mingling going on, but you got to stop now, because we're going to have more presentations. We have some wonderful content coming up on this stage, and not from me, so it's a lot of better content. I will try to squeeze in a joke or two now and then, just to lighten the mood. Yeah. Nice crowd here today in Vienna, eh? How many were you to the Christmas market yesterday? Raise your hands. Okay, so this side is for Christmas, and you guys are Grinches, or what? No hands, almost. Okay, a couple. Yeah, Liana, Chris, of course. But definitely check out the Christmas market, and there's more than one in Vienna, by the way. So, yeah. And speaking of Vienna, what a great city, huh? So, is there anybody here first time in Vienna? Oh, wow, so many of you. Well, I've been here at least once before, maybe twice. Can't remember all the times, maybe. I don't know if it's a good thing or a bad thing. But I've had a lot of fun in Vienna, and I love this city. And we're really happy and proud that Vienna as a city is hosting us. So they're really putting effort into it, and the dinner is going to be in the Rathaus, fantastic venue. So it is with great pleasure that I will introduce the first practice tag presentation from the city of Vienna. And Roman Schneider is here going to deliver it. And I asked Roman about how to introduce him, and he said, well, I'm a nerd, and I love nerds. I think nerds rule the world, and I'm really happy, Roman, that you're here, and I'm very excited to hear your presentation. So please, take it away.
It's a great pleasure for me to be here on behalf of the city of Vienna. Today I want to introduce you the openBIM building procedure. My name is Schneider. I'm working for the building authority of the city of Vienna. And today I want to introduce you to the efforts of the city of Vienna regarding to the integration of building information modeling into building permit processes. So the last 1.5 days we have heard a lot about the digitalization of building permit processes. We heard a lot of BIM, so I won't repeat that. I will start right in the middle. And one of the most important things about this are requirements. Well, our daily business as a building authority is, of course, checking building permits. So we have requirements regarding to them. And of course, if those requirements are made with a model from the BIM method, we have requirements regarding to them too. So let's take a look at them. We want, as a building authority, of course, have a model we can work with. So there are some necessities regarding to that. And the model we want to have is the building application model. We call it in English. It's a nice German word too. The 3 BAM is the same in both languages. And it's based on the architectural model, of course. We created a document where every information is laid down. So let's take a bit look inside. In this document, you will find all the information that is needed to create this building application model. So for every element, there is a title, the reference for IFC, of course, a description of the model and of the element. And if you're really not sure what it meant, there is a display of it too. And at the end, of course, some examples for the features that could be handed inside. So we provide all the information of the element classes regarding to level of geometry and level of information in detail. And of course, in the appendix, there are further information that could be handed in. And referencing to yesterday and the 2 very nice speeches to that, we handed out as a PDF, as an Excel, and of course as an IDS, as was shown yesterday. So take a closer look at it. In the end, I will provide a QR code for that. So why? Why do we want specific information for this model, and why has it to be a specific model? So, of course, a model can be checked. I guess you all know that. And the idea behind this, of course, I repeat it quite shortly, is you can fully automatically check a model. So the rule says yes, no, 1 or 0. You can, of course, make it semi-automatic. So there is an information that is needed for this process. Maybe you get an information in the end or have to make a decision between. So there is the part where a person is included in the whole process. And maybe it's not a rule, but it's quite helpful. The classification of elements and showing them in a specific way so that the person behind it can make a decision based on that information and that display. So the greater idea behind it is that if all the informations that we need are inside this model, we can start the checking. We start this process with, of course, there has to be a model. So on the side of the planning, a model is provided. On the side of the city of Vienna, we got a web portal where you can upload your model. And behind that is a checking software that applies all the fully automated checking rules to this model. And you get your check results. You download them, you can make your own corrections on the model. And this is a fully voluntary self-check. So no building authority is included in this whole process. Why? Because you can enhance your own model to have a better quality, less mistakes in it. It must not be a mistake made by the person who modeled it, maybe an export mistake. So if you're done with that and you're sure your model is right, you have all the documents that are needed, take the same portal, upload your model, and start the whole application process. So you submit in your model, your documents, and for now, the building authority can start its process. Now the process of the building authority starts. We do the same thing. We check the model. This time, of course, all 3 variants of checking methods. You get the feedback if necessary, and you can start the whole process with our feedback again, so self-check, of course. And in the end, we have a better model. We have a good option to hand in the permission for the building that is planned. You have seen in the background there was the solitary field of a checking software. Of course, we have requirements regarding to this checking software too. So one of these requirements is the documentation of the complete results, positive or negative, of course. We have the checking rules must be created by the building authority. Amendments can be made, of course, by the legislative, but there are courts too. And maybe there is a court decision that says, tomorrow things have to be changed. So we need to do this change on our own. We cannot rely on a company that wants, of course, money, but needs time for these changes. This can't be a way we can afford it. And, of course, versioning. We need those checking rules. They may change because of legal changes, but those processes may take a while. They maybe go to the court, and there have to be checked again, but with the old rules, and so on. Of course, there were many others, not only those 3. And in the end, we went in, of course, through a market analysis. And the market analysis said 2 things. Develop yourself what is necessary. And we need supplier independence for our core processes. Regarding those core processes, we have the rule editor itself, of course, and a web portal where you can hand in your own model. Both have to be developed. So let's take a closer look in the complexity behind checking software. We have seen, of course, some of them. So regarding to the checking software for building authorities, the structure behind is quite simple. We said we need functions. So if we want to make our own rules, there need to be functions, like filter for an element or an information, a formula that might be needed, or geometry that has to be used, found, created, whatever. Those have to be made by the developers by themselves. But those functions can be rearranged, grouped, used. So we create function blocks. Those function blocks give us a result. And we can regroup them over and over again with other functions and function blocks. And in the end, we have a rule, a result. Something that says yes or no. It's right, it's wrong. Take a closer look at it. There might be something. And those rules can, of course, be grouped into rule sets. So some parts of a legal code can be grouped together and used. So I want to show you an example of that in a moment, but the major part is the right 3 columns are made by the building authority. So it is our duty to do them. This is part of our legal text. It's from the Vienna Building Code. And bear with me, it's a part of a sentence in German that is translated. So please, no grammar devils here, I hope. But the major parts are highlighted in bold, but I will underline them too. There are 3 major informations inside this sentence. You have a build-up area, you have a building site area, and you have to compare them with a factor of a third or less. So it's quite easy to combine them into a kind of equation. And say I have a function block that gives me the result of the build-up area, another that gives me the result of a building site area, a function that makes an equation out of it, and in the end you have a check result. That's a rule, quite simple. Yes or no, does it work or not? And of course, in the end, the results of this rule can be handed out in IFC and a BCF file. That's the idea behind it. And for all the ideas, all that have you seen, there are of course necessities for components that are needed for our pilot operation phase. Spoiler alert, it's working already. So we need the checking rule editor, we need the website, and of course we need a model viewer. We want to look at our models and have a look how the building would look like. The first two are right now in development. The last one is not necessary. There are a lot of products out there in the market that can be used. It's not a core component, but the first ones are. And right now they are working. It's not a mock-up, it's not just an idea, and I will show you a bit more of it. So let's start with the editor. We have a menu, quite simple. We can add a function and we can start the whole process to see if our own rules are work. And if we combine those elements, we call them a module. A module can be a function or a function block. Together, we connect them. We have other options inside, but that's the quite simple one. You have a function block that can be used. In the end, as I said, you have a rule. The rule says, as part of our legal code, is it working, yes or not? And those rules, as said before, are developed by the building authority itself. And most of them, and that is our primary goal for now, can be used for the pre-check. Because there is the greatest potential for having good quality of all those models. And there is, of course, the web portal. Let's take a look to that too. I have to make a disclaimer on this point. Of course, the website is programmed in a way that it can be multilingual, but right now it's just in German, and I asked Google Chrome to translate it just for the screenshots for here. So bear with me if there is some weird text inside. It's just for the screenshots. On the future web page, by the way, it's already there, ActBIM-Vienna AT. There you find this page. In a few weeks, it will be available for the public. Right now, it's just available for us for testing. If you scroll down, there will be an option to hand in a code. So those are individual codes we hand out. And if you proceed with this code, it's an exemplary code, it's not working, you create your own project, you upload your IFC file, your model, you choose the checking rules you want to run in the background, and you start it. And a few moments later, you had a full model pre-check, you get all the information. Of course, you get your own IFC file, you get a BCF file with all the errors the software has found, and a PDF, of course, for documentation. So you can download it yourself. And this model was not delivered to the building authority, though there is a checkbox. If you want to voluntarily submit it to us, of course, we would be glad to have a look at it, to learn more about it. So this is my last slide before the end. Our next steps until the end of this year, where this project ends for the first. A public web service. It's already working. It's not just for there outside. The model submission and initial checking is working. We have tested that. And the friendly users, we are looking out for them right now and in the future. This is one of the major steps. And of course, our MVP, we are creating our own rules as a building authority. As said, this is our main point in the whole process that has to be done, has to be tested, has to be verified. And if you see it, there's a black one there too. They created a dark mode for me. Yes. And as promised, this is the last slide. So this is the end with a nice view over Vienna. I want to give you the information. On the left side, you have the QR code linked to the use case management of Building Smart, where you can download our document and the IDS, of course. This document is in German, of course, but just take your favorite AI system for translation and you will get the information that is needed. On the right side, you find the QR code for a contact for me. If you have any questions, or if you're interested, if you want to get in further contact, please don't hesitate, write us, give us the information. And of course, I'm here too, so if you want to have a nice chat or talk about it, I would be glad. Thank you very much.
Thank you. Thank you, Roman. Great presentation. Wonderful to see Vienna progressing so fast. Amazing stuff. And I know we don't have time for questions now. I'm sure there's a lot of burning ones, but catch him during the lunch breaks. And Vienna is all around us, so he's not going anywhere. But I just one quick question. Is any of that development going to be shared open source with others as well?
I'm not a developer, but the complete idea behind it is that it's first modular and be made in a way that other cities, countries, communities would be able to use it. That's why we insisted on that capability of being multilingual too.
Perfect. Thank you, Roman.
Thank you.
So, next up, we go from Vienna to another wonderful city in a much warmer climate, I must admit. But, you know, Christmas is very nice in Vienna, summer also, but they're warmer in Madrid. So, with pleasure, I would like to introduce Rebeca and Marta to come and talk to us about a project that everybody's eager to hear what are the latest developments for Madrid DBP. So take it away.
Well, morning everyone. We are Marta and Rebeca, architects from Madrid City Council, and today we would like to share with you Madrid DBP, our journey towards digital building permits that we started 5 years ago. But first, some context about Madrid. Is the capital of Spain and the second largest city in the European Union, with over 3.5 million inhabitants. We have 13 new urban developments going on that will eventually deliver more than 170,000 new homes. However, we are facing, like many other cities, a major housing crisis. One of the country's biggest challenges today, and as Pablos Velayos and Jan mentioned yesterday, is an European Union challenge as well. And like many other challenges, it has different phases like these ones. With Madrid DBP, we are trying to focus on resolve one of them by making the building permit faster and more efficient so these new homes can deliver sooner.
Well, Rebeca. Sorry. Hello. Rebeca, I think the time has come to talk about feelings.
Excuse me?
Yes, feelings, because most of the times when someone has to apply for a building permit, it's pretty much like this.
Well, we can assure that at least even in our department it's not like that, but is how usually people feel with these long processes, the complex regulation, and a huge amount of paperwork.
And Madrid DBP is the answer to that frustration. We want to make the entire building permit process much more simple, more efficient, and faster for everyone. I dare say that most of us here today are working toward this very same goal. And why Madrid DBP? We've shared some facts already, but what do we really want to achieve with this project? First, simplifying urban planning rules. by turning paper regulation into a machine-readable language. Improving project quality and feasibility, because better projects means shorter processing times. Faster permit approval, easier and faster approval building permits. Accelerating housing construction and delivery, so these homes can reach people sooner. And finally, and very important, ensuring efficiency, transparency, and legal certainty. And how are we going to make all this happen?
Well, let's introduce MADRID DVP.
Sound.
And now something very important. What are the main features of MADRID DVP platform, Marta?
First, it has to be an openBIM solution, because as a public administration, we must guarantee the technological neutrality. So models must have an IFC format, and we will use also the BCF for the communication and the IDS to guarantee the quality of the model.
It also has to be scalable. We are going to start from a minimum viable product, MVP, focused on the essential urban requirements of the city.
The system architecture is key in our system. It has to be at least a partial open source solution with a friendly user interface, and of course, legal security must be guaranteed throughout the process.
It's going to cover the whole life cycle of the building, from the GIS to the BIM to the digital twin of the city.
Of course, it must have the technical support.
And a platform management office, including the training programs and the media campaigns to support the adaptation. And a scalable platform, we need to take step by step to guarantee the success. So, as I mentioned before, we are going to start from the essential urban requirements. These requirements are the key parameters of a building permit in Spain, well, in Madrid. That includes the building plot conditions, the position of the building on the plot, the occupancy, the buildability, the volume and forms, and the courtyards. Those parameters were defined in our new building permit regulation approved in 2022 that also include a new permit called the Essential Urban Permit, which for the first time, it allows the construction to start and begin just after verifying these core parameters. So the stakeholder has the opportunity to start the building sooner.
And now let's dive to the more official part of the project, the contract that makes all this possible. We've launched a public contract, specifically a public procurement of innovation, which is the procedure used in public administration to acquire innovative services. So the contract has a duration of 4 years, plus a possible 1-year extension, and estimated value of 9.2 million euros, but excluded. We are right now evaluating the proposal, and the expected start date is the first quarter of 2026. And what are the main components of the platform? It is divided in 4 main parts. Component 1, the platform creation. This is the most important part of the contract, the creation of the platform itself, and it includes the development of the architecture, custom functionalities, user interfaces, and the integration of standards. It will be delivered by MVPs, 4 MVPs in total, each one developed in 6 months. This way, we can test and validate each stage before moving to the next one. And we will start with the parameterization of the regulation of a specific new area of the city situated in the southeast of Madrid, and it's called Los Berrocales. And after that, we will expand to the regulation of 5 additional areas, with the highest expected volume on building permit application in the following years. The component 2, support and maintenance. This includes the ongoing support, maintenance, and also the BIM software licensing that will be needed during the development of the platform. Component 3, evolution and updates. All improvements will be covered by this section. And finally, component 4, the platform assistant, which includes the training, communication, both national and international, and the PMO. And an interesting news is that we are going to create the network for cities and countries interested in DVPs. This way we can share knowledge, generate synergies, and also inspire other cities or countries that are interested in implementing this kind of system.
And now let me walk through the system architecture of Madrid platform. First, we have the developer portal. It's divided into 2 areas. The public area, accessible to everyone. Here, users can access to legal information, download the official IDs, or use the City geoportal. Then the private area, that requires a legal registration. Here, developers can upload their BIM models and validate them, download their issues in a BCF format, and get the final OK called the Urban Feasibility Report. But for me, the core of the platform is the rule engine, where all the rules in a machine-readable language are stored. The platform also has a 3D viewer and a support center for technical issues, and a municipal domain area where authorized staff are going to be able, is going to be able to change the IDS rules or the urban rules. And finally, we are going to have a BIM repository with to store the final 3D models to fit the digital twin of the city.
And now that we've seen what the platform offers, the next question is, how does the whole process work in practice? So first, developers must electronically register in the developer portal, and there, as Rebeca said, they can upload the BIM model in IFC format, and after that, the model will go through the Madrid IDS to guarantee the quality of the data. If the model complies with the IDS, it will move on to the next and most important step, the validation of essential requirements. This phase will be done using data from GIS Madrid and a rule engine based on the regulation that applies in each case. In this stage, the system performs the architectural and compliance checking. And if everything is correct, the applicant will receive an urban feasibility report in BCF format. And if anything is wrong during the process, all the communication will be done also in BCF. This way, the architect can make all the necessary adjustments and resubmit the model until it meets with all the regulation.
And as you can see in this mock-up, Madrid DVP platform will place the building into the Madrid's digital twin, and then the validation starts.
We started with our slow-moving friend, a perfect reminder of how people usually feel when applying for a building permit. And now it's time for good news. Thanks to Madrid DVP, that feeling is about to change. Faster, more efficient, more transparent, smarter cities, less paperwork. That's the goal we are all working toward. Thank you very much.
Thank you.
Thank you, Rebeca and Marta, for a wonderful presentation, and I'm really excited about this practice track. I mean, first Vienna, now Madrid, and others coming up. Really exciting stuff, and yeah, Roadrunner, he's an instigator, right? Do you feel like you're a bit of an instigators within Madrid city as well? No? Is it well received within all the other departments?
Well, some people were like, so with this Madrid DBP, what are we going to do? We don't have new building permits to do, but yeah, finally everyone is involved, yeah.
They will be able to focus on the most important part of the process, so it's not a problem.
Well, it's wonderful, and I must say, it's good they have instigators like you within Madrid, showing the innovation and leading it, and well, really looking forward to further developments. So thank you again. Next questions, you can ask them directly. I really encourage you to reach out to Marta and Rebeca, and yeah, thank you again. So, from one city to another, and now we jump into Germany, the city of Hessen, I'm sorry. And I would like to welcome on stage Simon Sauerbier. Glad you could make it here, and I'm excited to learn what's going on in Germany. We already got a small peek, a small teaser from Andre yesterday about all the pilots going on, but I'm really looking forward to your speech, so please.
So we just try to think about getting the jump from lighthouse projects like Vienna, like Madrid, how to spread it into a whole state. So if you just consider about that, I'm just governmental counterpart over here, and I just try to get into it what work we have to do, but what work we have already done. And we try to show you where, at what stage we will be in future, we are working on. And things, if you have lots of money, you have lots of interests concentrated in one place, it's much more easier to have high, or to gain high data quality, and to have all the people who are very cheered up to use the new technology. And well, I'm talking about the technical dimension, of course. You did it all the time. I'm talking about regulatory things we have to consider, and we have. I'm talking about three other things. It's change, change, change. That's the success key to come into, to spread into the areas, because you won't do it just when you can't develop an economy when you are just pointing on one central. So how do we go around in Germany? And just to figure out what we are doing, the key is to get the requirements from the stakeholders. And we are a small team. That's our problem. We don't have lots of people, but we have a good structure behind it, and we have lots of experience and data in data sets, data security and stuff like that. Everybody's using us, but you don't know it. But you rely on us, and that is one point that we are having a good structure in Germany. And our point was, okay, Germany or maybe Hessen is just organized from bottom to top. That is not that easy, because you have 3 million people living in Germany, and if you are a sub-entity which is owned by everybody, you have 6 million chiefs. But especially when you are looking into evolution, it's a good thing just to get the requirements from the authority people, from the architects, and maybe just to simplify what techniques you have to involve at what stage to come around with the whole thing we have to proceed. Well, what's the thing is, we think the data cycle from the beginning to the end from an authority point of view. seamless transition in data. It's not our task just to gather every data. We don't need it as authority. We just need our bit for the building permission. That's our point of view, and we try to combine it using interfaces, and that's a pretty German thing, do everything standardized, but in that case, if you're coming from the bottom to the top, it's a kind of accelerator when you're heading into the worst country. And Hessen just rely on federal standards. We are developing it with all the states together. And well, and that's a good point for all the private stakeholders because they have somebody who is capable just to fit be the testing counterpart for developing his own system into a whole process. And the thing we do over here, it's a modular system where our main object is data security and assembly all the technologies at the right manner into the system. And in Germany we have one thing, we try to lower boundaries. Ideas should come into place and develop very easily. That's the thing. We want to have nice houses, nice economy, nice production place, and these things need low boundaries. And it's a high problem just to take care of your authorities concerning IT data security, and we do this with protocols nobody knows, but we know, and it's working. And but we have to connect the people who are entering from the World Wide Web. I tell from me it's the Wild Wild West because we don't know who is behind the screen, but we try to check it out that the data who is arriving us will be clean and could be also used over the process, not just the permission, all the reports to steer up economy in a right, accurate manner. In the thing of when the build is, or you're going over the construction, you can use the data if you know it's right. And afterwards, you just take care that the data will get back to the applicant afterwards as well. And that's the thing we are thinking about. And nowadays, we are talking about GIS systems, BIM and pre-checking, how we're going to proceed with that, and where we see our hurdles. Just going into every country, we managed to kick out paper work in at least now 18 authorities, and there are lots of in front, and I think we will gain it in 2026 or 2027, the last ones. So it's like a dynamic process, and we are working on level 3, level 4, and the maturity model. And what is the topic we are working on it at the moment? We try to sensibilize that authorities or governmental part has also to do a specific job by providing good data, high quality data which you can use afterwards for your BIM models to lower boundaries. Because we have now 5,000 applicants or permissions proceeded at the moment. And how do you think, how many BIM models are used by it? 3 at the moment. That's really, really, really less. Yeah? And all the authorities are very happy that they have a seamless process. It's fantastic because there are lots of acceleration in it. That's the first thing, but we have, bear in mind, we are organized from bottom up to the top. We have to take care that everybody is coming with us. Very hard work, so we just checked up that you can provide your IFC data. Now we are try to combine GIS data and BIM data in a good manner, and how that should work. I think Vienna and Madrid has solutions for that. I'm very keen to talk about that. But the thing is, just now in the video, you will see what authorities are doing to have a really quick process. And we just started, and meanwhile, I just tell you where I see there are the hurdles which we can be kicked out if we're working together. You see a model made by Revit, and the first thing, that's your business, you know that everything, but the first thing we are going to do here is try to get to northern your project into the GIS system. Not that easy thing, but it's possible. It's not really a problem if you have two geographic points. You have to consider about transformation and stuff like that. You have to work out Arcus tangents. Could be quicker. Yeah, could be quicker if the government provides an IFC cadastre or a 3D, three-dimensional model, but it costs money. We have to tell the people or maybe the government that it's interesting to do that, because it's just the basic data we need in the future. We see here how the model will be north, and now there will be some, that's the X and the Y coordinate, and the thing is the Z coordinate. Very interesting thing. We have digital terrain models, but you have to pick it up. It's not. That's the reason why we need the BIM IFC, yeah, the IFC cadastre, because this takes time, probably half day working. Why is that so slow? Yeah, could be quicker. And that's the thing is we also need the private industry that they start to develop interfaces in a standardized process. So we need every stakeholder inside, and that's the thing I want to point out here. Okay, now we are doing the northern stuff, and now we have the possibility that an authority is very shortly capable to switch the model into his common GIS system, and there are problems either. In big cities, they have good quality data, probably not a problem. But what you do is see over here, we have here flood risk. Oh, yeah, now it's gone. Flood is fading me away. But flood risk is just a good example. It's a high quality data. It's vectorized from that point of view. We can use it. And it's really easy for pre-checking if you just provide it at the front end. If you have like an adapter, where you can show it, from the architect and the people who wants to build his site, just to see, okay, if I'm doing that, I have to do something technical. Yeah, much more expensive. I just go to the neighbor and ask them, I have a very sweet black suitcase, 50,000 euros. We shall talk, yeah. And so you make things happen in a good manner. And that's the thing of it's everything. It's allowed to earn money. It's no problem. We are used to it, and that's our business. And the governmental likes if you are wealthy and you have a good product. But the thing is, it has to be standardized in Hessen, and that's our way. We want to cope up with. So at the BIM stage, we just going beneath many other projects here in the room, but we are fast following, using your results. What you are doing is fantastic. Proceed it. Because we just step by, all right, it costs money, all right, but we just step by 4 or 3 years later on. So it's a good accelerator. And if you think in evolution of authorities, it's just the thing. If you digitalize an architecture office, it takes you 4 years. If you digitalize an authority, it takes at least 8 years. It's another scale of time. Okay, and well, what are the points I just want to tell now? We are using standardized process standards XBau and XPlan for land use. I think it's a really good thing in Germany to get standardization spread out overall at every pavement, and that's a thing we try to check up at the moment. I think we will give a report next year in Gießen, and we will see what we gained over there. And then Jan Saad, sorry. Now it's 10 and 1 second. I hope it's enough.
No, it was perfect. So thank you, Simon. I just get carried away by all these cool use cases that I forget to monitor for time. So we're way over time anyway. But I really liked your presentation. So I think it's wonderful what's happening in Hessen. Yeah. So it's more than one municipality. It's like a bunch of municipalities. Or is it one municipality?
Pardon, one?
One municipality, or is it a bunch of? It's a region, right?
36 municipalities. Okay, lower authorities. We are spreading all Hessen. Yes.
Okay. Well, fantastic. That's more than. It's a state.
It's a state.
Yeah. Judith, thank you for giving me insight.
You know Frankfurt?
Yeah, I know Frankfurt.
Close to Hessen.
Yeah, which Frankfurt? There's two, right?
Yeah, you're right. No.
I know a little bit about Germany.
With the airport.
Yeah, well, I'm coming from Estonia, so it's just the whole country is smaller than one state. So, but thank you again, Simon, and you'll be around. So people, I encourage, we skip the questions in the room. It takes a lot of logistics, a lot of time. So I encourage you to connect person to person, exchange contacts, and ask all the questions from Simon. So thank you again. Okay, so it feels like we're kind of stuck in Europe a lot. So next up, we're going to take a trip all the way across the globe to two gentlemen who've made a really big effort to come here, haven't you? Yes, so please come on stage, guys. So I would like to introduce James and Michael. And they're coming all the way from down under, right?
Correct.
Yeah.
Is this working? Can you hear me at the back?
Yeah. Well, yeah.
Can you hear me?
Cheap seats. Can you hear them?
Can you understand my accent?
There's room here in the front, by the way, if you can't hear them. So come on,
please.
Don't be afraid. Yeah, I'm sorry. Can you speak English? I didn't hear that.
Just Australian.
Okay.
So we combine
away,
words
guys.
together and add an O to everything. So if you don't understand me, just there's a lot of pictures in the presentation. So hopefully that works. Firstly, we just wanted to say thank you. We have travelled a long way. I know that there is a lot of information being relayed. So if everyone's getting a little bit tired, hang in there. It's 10 minutes. We've travelled all this way. So if anyone falls asleep, I'm going to come and shake you. Jan, I'm really pleased that you were introducing us today because your presentation yesterday resonated with us a lot. The core message around starting, I'm not going to do my Arnie impression, but in starting early and then incrementally improving or increasing the number of use cases or process steps that you could augment with AI is exactly how Michael and I have started. So before we get into how we'd like to spend our 10 and hopefully half minutes, we wanted to provide some context on who we are and why we've travelled all this way. Let me know if you've seen this before. Seems like a bit of a recurring theme. A big problem in Australia at the moment is housing shortage and housing supply. And it is resulting in young Australians leaving hubs and moving overseas in some instances. So our government is incredibly compelled and investing heavily on many different levels on solving that problem. And one of the ways they're doing that is investing in artificial intelligence to help address or accelerate digital building permits and doing it now and looking at tangible actions that can be implemented now. And so Michael and I are here to talk about a case study. We are wrapping all of the theory that has been spoken about today and hopefully showing you in a demonstration and with some results on how Wingecarribee Shire Council, I'll give anyone $5 if they can say that, have been using our tool. So the three things that we want to focus on today are the results and outcomes of our AI assistant. We want to share the lessons that we've learned so that you don't have to learn them in the same painstaking ways that we did, and then discuss future opportunities and integration with things like BIM. So what is DAISY conceptually? Michael's going to spend some time actually illustrating what the solution does, but essentially she is a trained model that helps interpret zoning regulations for any block of land specific to a council so that applicants and planning authorities can interact more efficiently. and also do downstream actions like document generation, document validation, those types of things. So it's a full end-to-end digital workflow that has AI tools embedded in it. And we've been able to build Daisy with the help of our consulting partners, Adaptivate. Say hello, gentlemen. And so it's all about how do you map a business process and then understand the parts in that process that really should be augmented with AI. Start with the simple use cases first and then continue to expand, similar to Jan's messaging yesterday. We're pleased to share that in the 3 months since we've been live with Wingecarribee Shire Council, their assessment timeframes have already improved by 20%, which is considerable given we expect a large increase in adoption. And again, I think it was maybe Pablo or Miguel yesterday who was speaking about addressing the low-hanging fruit. We were able to reduce those timeframes, solving relatively simple tasks, which we'll demonstrate in a second. And the second data point is that because Daisy is a 24/7 agent and she's always able to engage, the number of inquiries that were resolved first time outside of business hours was at 49%, which has two key benefits. The first is that your applicant experience goes up, so your community experience with planning departments increases. And the second is that you remove the time suck away from manual and basic inquiries. I am now going to hand over to Michael, and I'm going to preface the handover by saying that this is a very accelerated demo. So we would like to meet with anyone who would like to get more into the detail and talk about how we built it.
Thanks, James. So I'm going to go through a demo now, and this is of an applicant that's trying to build a house at 12 Betty Close, which is an address in Wingecarribee. And so I'll focus on two things. The first is we've set up Daisy so that she could answer applicant questions using AI, and really the point of that is to try to save time for staff members so they can focus on the important thing, which is assessing applications. And the second piece that I'll focus on is how we improve the quality of applications when they come in. And so what we can do is we can improve the quality by checking documents, and that means that we'll have higher quality applications that come in and less back and forth between councils and staff. I'll flick to the next slide, and this will be the quick demo here. If you could press play. And so the first thing that will happen is you'll see the chatbot is on the council website, and what we do is the user will go in and they'll input their address. And what that does is it pulls in all the context about the property, which really enables the AI to have a really clear understanding of what that property is and what the characteristics are, so that they can ask specific questions about the property and get an answer to their questions. So you can see you ask, can I subdivide my land? And the AI will look into the information about the property, search the legislation, and then surface an answer with a citation to that. From there, they'll come into the platform where they can see information about their property, and Daisy will guide them through the process of identifying what type of application they might need. And really the benefit here is that we're trying to bring this stuff up front and have AI answer these questions for people. So again, staff can focus on assessing the applications and doing the difficult parts there. So you can see Daisy's having a back and forth with the user, identifying what type of application they might need, and then next going into a document checklist where they provide information about the types of documents that they need, where they might get those, how they would get those, and when they might need them. Again, the whole focus is on trying to surface this information up front so that the staff can focus on assessing the applications and getting applications through faster. Once they've gone through their document checklist, they can actually upload documents to the document checklist, and this is where we start to look at the quality of the application. And so they'll upload a document, and what Daisy will do is then look at it using AI to identify, is that actually the document that they want? And then we can also check rules against those documents so that we can see if they're compliant with the rules of the law of the land, as well as any specific rules such as how old is the document, does it need to be less than a certain amount of time old. Once the user's gone through their documents and they're satisfied that they have a good set of documents that are ready to upload, they can submit it directly on the platform and submit that to the council, ideally with a high quality application that's ready to be assessed. So I'll go through some lessons learned. When we first started this, it took us a pretty long time to do the first one. It was quite difficult. We had some growing pains. So I'll go through some of the things that we learned along the way, and now we've gotten it to a point where we can get one of these up and running for a council in 6 weeks, which is really exciting. And so the first thing that we learned, the first lesson, is look for tedious, high-volume tasks and leave humans in control. So what do we mean by that? When we mapped out their process, we found a lot of things where we could really find easy wins. So an example here is just document naming. If we quickly name it into the council naming convention, that saves someone 8 hours of work that someone might spend time doing, and we can just quickly make it so that we have more time for staff to focus on, again, the important thing, assessing applications. The second part of that is how do we help staff with options but leave them in control? So our whole philosophy on how we build our AI products is focusing on leveraging the power of AI to surface the information, but then making sure that there's always a human in the loop control so that they can make the final decision of, are we going to implement this suggestion or not? And so that's the second focus there. For rule number 2, don't confuse AI. Use structure as much as possible. So this goes when you're building legislation as well as when you're working with it. And we found that there's a lot of nested clauses, a lot of really complicated legislation. And so one of the things that we focus on is how do we make that cleaner? How do we put it into structured data and tables to make it easier for the AI to read, easier for the AI to guide the user through the application process and provide better answers to questions. Rule number 3, again, don't confuse the AI, kind of a trend. Less data is more. One of the things we started off with is we just threw as much data as possible at the AI and tried to figure out if it could provide the correct answer. And in Australia, we have federal legislations, state legislations, local legislations. If you throw too much context at it, it gets really confused. So what we focused on is how do we find keywords and messages in the information that someone's inputting into the AI so that we can then filter out the documents that are the most relevant to that and really narrow the focus of the context that we give to the AI so that we can provide quality answers and make sure that it's guiding users through the process in an easy way.
Fantastic. So now you've seen the benefits that we've experienced with one of our municipalities. And you've heard from Michael on some lessons that you can each take back to your countries. But what's next, and how can you continue to expand the AI tools that we've built into other business processes and use cases? So we are piloting now an assessment assistant that basically takes all of the tools that we've built, that document validation, that understanding of zoning requirements specific to a lot, and then applying it to an assessor or an architect, for example. And so the first way that we're doing that is building a digital workspace, which you saw in the first example. But this pilot now is actually surfacing information at the fingertips of a decision maker at the point in time that they need it. So rather than spending time searching through long documents and comparing them against applications, they can do that natively within a digital workspace. And so it's really about bringing and orchestrating that experience so that it's simple and people can, again, it's a recurring theme, but focus on the critical items that they should be focusing on.
We're also working on adding graphical interfaces into DAISY. So we're working with our partner Graph here, and what we're trying to do is have templates that we can drag and drop onto a map. And essentially this does two things. It'll allow people to test compliant developments, which will really streamline the process for how they can get an application approved. And in addition to that, having the data be in templates makes it structured data similar to what I was talking about before, where it's really easy for the AI to read and understand and provide, again, quality answers and guide people through the process. We're also working on localizing DAISY. So we currently have a pilot in progress in Poland. We're also working on localizing DAISY for UK and US processes. And so we'd be really interested in talking to anyone that's keen to have an understanding of how we can localize it for different languages, but also the subtle nuances between the processes which we see across the world.
Fantastic. Thank you, Michael. I think I only saw 2 people fall asleep. So sorry there was no Roadrunner, but we appreciate you staying with us. We're happy to take any questions unless there's absolutely no time to do so. Saw a lot of photos being taken. If you'd like the presentation, just reach out. Scan the QR code and we'll send it to you, and we'd love to have a conversation.
Thank you, guys. Very nice presentation. Practical use of AI. I like it. I'm not going to get the $5. Damn it. I was practicing in my head, but now I forgot. Yeah. But I would like to hear your Arnie impression, though. Okay, maybe later. After a couple of drinks. During the dinner. Yeah, but if somebody has a burning question they want to ask from the guys down under, you can raise your hand really quickly if you want. And if not, no, then please approach them. You're going to be here for a while, right?
Yeah, we're here tomorrow as well and coming to the dinner tonight. So
all right, perfect. So thank you, guys. Much appreciated. Long trip. Hope you're not too jet lagged. Well. Well, it's really a global phenomenon that is happening around digital building permits and the automation part. So, but we're going to stick around in that part of the globe. So the next presentation is also coming from Australia. Ah, there you are. Abdoulaye? Yeah, thank God I pronounced that more or less correctly. So you can continue in the complicated Australian English, which we try to figure out, but no, it was really good, the guys. I understood like 70%, so that was great. So take it away, Abdoulaye.
Yeah. Thank you very much. Hi, everyone. So I thought initially that I was an outlier in this session, but I was very happy to see the folks from down under. So yeah, so my name is Dr. Abdoulaye Jakite, and I'm leading this small company, City Geometrics, based in Sydney, Australia. So it's very cold for me here, actually. I'm originally from West Africa as well, so it's cold anyway. And I'm specialized in BIM, GIS, and digital twinning. And my main interest is geometry. So that's why this topic today will be about validating geometry in BIM. And when I say BIM, I mean IFC. So I'm going to skip the content because I don't have much time. So why geometry validation matters? Intuitively, we know that it matters because many processes rely on geometry in general. It's particularly true for DBP because the checks that are performed are running geometric operations, so they rely on the geometric data. But there are many other processes that rely on geometry in general. A good example is, for example, path planning or energy simulations, though these processes heavily rely on the geometry. So it goes without saying that if the geometry is wrong, the downstream's use cases and applications are very likely to be wrong too. This is well understood in GIS, so there are many processes that are really focused on validating the geometric information. These are a few examples, so they are backed generally by OGC standards, and if you are used to databases, PostGIS for example, there is a famous function, STValid, that makes sure that your geometry is valid. And Val3DT, which is a nice development from TU Delft, which is focused on 3D city models. But in the case of IFC, it's slightly different. So in general, when we talk about validating IFC, we really focus on the form. There are tools available, and they will be validating the schema, they will be validating the semantic, but not necessarily the geometry. For example, if you look at IDS, IDS explicitly doesn't support geometric validation, so it really stays at the level of the properties. But because of that, somehow it feels like people are assuming that geometry is generally correct, but it's really not the case. In practice, there are many issues with the geometry. So this is a small list. It's a small list because it's not the exhaustive list of some geometric issues that may happen on an IFC file. And one particular thing with these issues is that they are not visible. You cannot see them. So when you look at the model, as long as your wall is not flying away, it looks fine to you, right? But in practice, there are a lot of small issues. So an example is here, for example, inconsistent face orientation, the one at the bottom. There is a research group in Germany. They did this small experience, and they took this small house on the right. They computed the volume of this house when everything looks fine, when everything is fine. And they just flipped the orientation of one face. And this is a difference that they get in the volume. And the tool they use is FME, which is very known, basically, and very robust in general. And the reason why FME gets it so wrong is because the algorithm that it uses assumes that the geometry is correct. And this is very common. So generally, the geometry predicate assume that the input is correct. But in practice, it's never correct, almost never correct. So this is one problem. And another problem is the way IFC is representing geometric information. So there are two families of geometry in IFC possible. The first one is explicit. So explicit geometry is just, well, it's entirely described in the file, let's say. You can just read the file and read the description of the full shape in the file. So whenever you visualize an IFC file, he's using the explicit geometry. It cannot be otherwise because the graphic card needs to interpret the geometry anyway. However, because IFC is coming from this CAD world, it's inheriting from this CAD computer-aided design world, so there is a lot of parametric representation as well. And the parametric representation, it's not the full shape, it's some simple shape and some rules that you need to follow to obtain the complex shape. So it's a process, it describes you a process. It gives you some basic geometry and describes you a process to get the complex one. So it involves interpretation, and that's maybe where the problems are. So coming back to the context of DBP, for example, this interpretation, what it means that if I want to validate the geometry, I'm not validating the file itself that was submitted to me. I'm validating my interpretation of the file. So this is very different. And the interpretation is done by geometry engines. So these are software. So you don't face this part of the software. You just open a tool, it visualizes your BIM. But in the background, it had to interpret the geometry. So it's a problem because the contract somehow between you and the applicant is the file that the applicant submits to you. But then, once you validate it internally, or the result that you are seeing is not necessarily what the applicant has seen on the other side. So this has a consequence because the DBP process in itself requires a single source of truth. So we need to make sure that we are talking about the same things. We need to make sure that the checks that we are doing are objective to some extent. But because of this setup, basically there is no guaranteed reproducibility of the geometry because the tools are working differently, as I said, and it brings a lack of reliability in the process. And that's not very, I mean, it will be fine if it was just about visualizing a model. If you are looking at the building, there's a design, yeah, it looks good, I want something higher, lower, it's fine. But because there is this legal aspect involved, I don't think it's fine in this case. So it's a kind of a blocker. But obviously there are solutions. And one of it is pretty straightforward. Perhaps we should consider requiring explicit geometry in the case of DBP or any legal-oriented use case, because it's possible. The file can describe the geometry explicitly. This just for some reason that it's not done. But at least it will give the single source of truth. And if there is a problem in the file, it will be very straightforward to correct, because we all know where the problem is. We can correct it and read it again. The only downside to this is the file size, basically. So it can be bigger files, but it's a choice. Either bigger files, no ambiguity, or smaller files and some ambiguity. The second option, to me, is less interesting, but it could be maybe enforcing the use of the same geometry kernel. And the geometry kernel, this geometry engine, as I said, is part of software. So this is just saying using the same software for the applicant and for the municipalities, which guarantees the same, you will see the same things, that's for sure, but it's less interesting because you are restricting the software that people can use, and I don't think this is the way to go. And even the corrections are a big problem because you are not correcting the problem itself, you are just adjusting basically against the geometry kernel because you cannot change the geometry kernel, you are just using a software. So why I'm telling you all of this, and while it is a practice session, so I ended up doing some research in this problem because initially I'm working on this tool, which is named IFC Web Tool, and the purpose of this tool is just a web portal to drag and drop an IFC file and perform some processes, visualizing, analyzing, validating, simplifying, converting. But then when I went to the validation part, I realized that I was validating geometry engine rather than the file itself. But that's not my interest. I want to validate the file so that we are sure that we are speaking the same language. So you can scan it, have a look, and follow it. You can drop your email there, and I will put you in touch definitely whenever it's released. But this is a work in progress, and some parts are already done, like the conversion, for example. So that's the practice part of the session. It ended up looking like research, because this problem to me is worth considering and discussing, mainly in the scope of the DBP. So thank you very much. I will stop it there, and do not hesitate to reach out, because if this is a matter of interest to you, I'm very happy to keep the discussion forward. Thank you very much.
Thank you, Abdoulaye. So that was really, really interesting, the geometry part, and something, well, I sometimes don't pay attention at all that much. Thank you. And I appreciate you making the effort, coming all the way and being cold here. And yeah, you should come to Estonia or Finland. It's warm here. But thanks again, and you're around, so everybody, Abdoulaye, and get in touch with him if you have questions. If you missed the QR code, you know, you'll be happy to provide it, right? So, and there's plenty of materials afterwards. After the conference program, you can find it. And look him up on LinkedIn. So, there you have it. Thank you again. So, so now it's off to lunch. No, I'm kidding. I just wanted to see Chris's face. So we have one more presentation before we are off to lunch. And I'm happy to say it's coming from my, my good colleague and friend, Christopher, from Estonia. And Estonia has been doing BIM-based permitting for a while. We started developing it years ago. And I think you're going to give us some insights on how it's going. And it's always not a smooth ride, is it?
No, it's not a smooth ride. And yeah, we started a long time ago, but I'm very glad to see that so many other practitioners have already surpassed us. So now we have the chance to learn from the others.
Well, I'm not sure they've surpassed us. I mean, they're still in the beginning. Estonia, Tallinn already has, you know, lessons learned, which we're eager to hear. But I know you like to talk, so I'm just going to make sure you know this sign. This one is the 1 minute sign. So if you see me raising it, you know it's time to wrap up, right?
And we are considering that 0 is not a number, okay?
Yeah, okay. So take it away, Chris.
Okay, thank you very much. It's nice to be on the stage, and especially after all these very amazing presentations. No, I'm not yet off this track, so it's really hard to somehow sum it up all together. But because after my presentation there will be a lunch, welcome to the kitchen side. Now we are actually seeing what's cooking here in Estonia. We are going through the gains and the pains. About me, I'm at the moment working for the city of Tallinn, head of the digital construction there, a lot of international collaboration with the organizations. Also, I'm proud to be part of the European network for digital building permit quite since the beginning. And straight to the point, so BIM-based building permit process. We started with proof of concept back in 2019. We started the procurement for the first version back in 2020, and we had it ready end of 21. Then we integrated it into our building registry, which is the national, I would say a little bit like digital building logbook, and it's combined with the procedural environment, so you can get your building permit through that digitalized system, which is used by all the municipalities in the country. I'm missing some numbers because I just forgot to send the organizers a little bit fresher thing, but it would be like, we already have like 4 BIM-based building permits, and there are some in the process. Why only 4? I will get to that as well. But like Jan already had in this presentation, again, like the key things, what have been mentioned here as well, like transparency, speed, the quality of the design. These are the main things. They were the same with the Austrian case, they are the same with the Spanish case, and looking under the hood, actually, we have very many similarities there. About the process as well, I won't go it through. Roman in his presentation already described it. It's identical. Pre-validation for the applicant, I would say great minds think alike, yeah. So about the governance, the ownership, the cost of the solution. So, we were taking this path of the custom solution. So we developed most of that stuff ourselves, of course with the help of the great partners. Future Insight was one of them. Jan even escaped there to join them. It is, one point would be, okay, we own our own solution, but not all of it. It's less vendor lock-in, but back at the time, there were like no good open source solutions for the rule engine. So we have to still have some proprietary solution there. And there are the pros and the cons. Of course, we have the procurement of the system. Well, if we want to change something, we have to have a quite long procurement process. And when we have some kind of vendor lock-in, well, it's not always the most pleasant way. And of course, when you own your own custom system, you also have to have enough funds to keep it updated, because it's IT system is like a building. You design it, you build it, and then forget it. And what about maintenance? Who cares? Well, the building needs maintenance, IT system needs maintenance, here it is. But about these things, what I heard about the MADRID, and what I heard about the Vienna as well, well, what if this open source solution of the rule check engine would be EU-wide? That the front runners could come together, develop it together, and then it could be used by the member states who are not that advanced, municipalities who are not that advanced, because otherwise Austria will do it with Austrian money. They will do it like they want. Of course, they are happy to share it, but is it really according to all of the needs of the others? Maybe, maybe not. But if we come together, we can make it so it would be available and applicable for the other needs as well, because what we have heard today, the needs are basically the same. They are so similar. I would say like 80% is the same. Same check, just different numbers. But how to make this happen? I'm really hoping that some kind of like European level institution looking around in the area, not naming names, gives us this kind of like funding. We will bring together a strong team, we can lead this, and all of the European problems would be solved. But what about the positive sides, the gains? Okay, 47 automated checks we have about the housing requirements, the accessibility, the fire rating. Then of course we extract the data from the model into the application, so there is like no double tipping of the information that exists already. What is missing from the slide as well is the geolocation. We have the geolocated model, so you can see that in the surrounding environment thanks to the National Digital Twin. Also, the common BIM requirements, the national common BIM requirements set this kind of like common ground that you have to use your properties in the IFC models to be applicable for the regulations. And I think one of the key things there is the simplicity. If we're like looking at these kind of BIM softwares that are mostly usable by the BIM coordinators, well, to me, they look very simple and easy. If I would give that same software to the typical building permit processor who has only worked with the 2D drawings, well, it's totally different language. It's really hard to use that. So we made our own UI, very simple, so only the buttons you need, nothing extra. If you're a BIM coordinator, you don't have to use that. You have your own software, you're using that one. But also, it's important when we're talking about automated checks, we're not automating the building permit process itself totally. We're automating the boring part, getting the information, searching the information. The decisions remain with the humans, and the humans can now put most of the time to make these decisions instead of searching for the information of this file and this drawing and that drawing, and every time it is a little bit different. No point of doing that. So a little bit about these kind of checks. So what are we actually checking? There can be like simple property checks, something we can actually do with IDS. We don't have any IDS in the system because when we finished the system, then IDS was still in the childbirth. It was coming out, so we couldn't use it. So for example, if we want to know the height, the width, or the area of the space, we have some properties. Also, when we want to check if the fire compartment zone has good enough fire resistance, again, there are some trigger conditions that have to be met. Then we get the requirements. We are checking the model if they have these properties, and then we are just showing the results. Also, there are a little bit more complex ones. So we want to know if the apartments that are on the 4th floor or higher are accessible via the elevator. So we are defining what is the purpose of the use of the building to trigger the code. What are the apartments? What is an elevator? Which doors are the entrances to the building? And then by the geometry of the model, we are connecting these dots, and we know, do we really get to that apartment via that elevator or not? About the geometry, also, we can use the voxelization. Of course, it takes a lot of computing power, but again, this is like really valuable outcome. I want to know, like, do the stairs have the handrails? Instead of like just checking if this IFC element is next to that IFC element, there is this kind of like voxel agent running through the model, and if we know what are the IFC stairs entities, they can just fall down. And if we want to know if something bad happens, can we escape quickly enough? Is the escape route short enough? Then again, we have the fire exit zone, we have the evacuation zone, and then we can just compute the length from the exit zone, do the evacuation zone, from that do another evacuation zone, and to the outside of the building. Of course, that is not being checked by the fire department at the moment, from exit zone to the exit of the building, but because we just can put that information there, we can show it, and maybe they are just recalculating their own requirements because their requirements are based what they are getting PDFs, getting this PDF measure tool from this corner here, 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 and doing that with all the things, several hours, 20 hours or something like that. So going to the panes. Everything looks fine. And then you go to the dentist chair. They look into your mouth and see like, okay, and that's not so fine at all. So about the checks, just continuing. There can be false positive checks, false negative checks. So for example, here we're seeing that there should be enough free head space. We are even taking some kind of like setback from the wall, but because there is a window, it just goes into that area. We're seeing that red thing. Well, it shows an error, but it shouldn't be an error. So it's just this kind of like a nuisance. We can't get rid of all of these things. False positives, so much more dangerous. Everything looks fine. Actually, everything is not fine. Somebody forgot to fill out some kind of property, and we are not seeing that space there because that category, that trigger mechanism is not correctly filled. But about the pace I mentioned, 4 building permits, 4 BIM-based permits. We have been live almost for 2 years. So when we have the custom solution, we have the custom problems. So we own all the good animals, and we also get the gremlins. So we have to deal with this. Then, of course, we introduce the BIM into the existing system. Then it's going to be like, okay, before I was looking like there is one information in the 2D drawing, there is another information in the explanatory letter, and third information in the application form. Now I have the fourth information in the BIM requirements. What is most valid? What is the single source of truth? This has to be communicated, and not only this has to be communicated, but all the solution, how to use the solution, how to go step by step. This communication is really important. I see Jan is waving already. The stomachs are empty. I'm trying to wrap it up, but I have a few more slides, so I go quickly. Also, the change management as well, time and teamwork. But the most important here is when we're talking about technology, this can be coded, but people can't. We have been hearing this a lot in this conference. It's about the people as well. It's not about technology, and the most obstacles are with the people. Of course, at some point we can be coded when we wake up and we are living in the matrix. Is it the solution? No? Yes? Maybe? But how to speed it up? Okay. There are the different options. I try to speed up my talk as well. So we have to communicate. The government has to take the initiative. It has to be clear. There has to be a clear framework as well. Of course, there have to be some kind of like referent projects and shared examples and collaboration between the different institutes to really make this kind of change happen. Also, what we need for the next steps to really make it BIM-based permit, not hybrid 2D drawings plus BIM, we need to see the 2D information. We have to have the realistic ground, and also a lot of checks are being done with the site, so we have to have the site model as well. This is not the usual thing in Estonia during the building permit phase, but it will be modeled later on. But maybe we just do it already, get rid of the drawings, have that information in the BIM, and only then we can replace these PDFs and be fully BIM-based. But how to put this machine together, how to really start it? Yeah. When you want to do it, just choose the right checks, make them very simple, make them very clear, have the different stakeholders together, lawyers, architects, public sector people, and of course, do it in an agile manner. And not everything can be digitalized. Start with simple stuff. What gives you the most benefit with least amount of effort? And just to wrap it up, the last slide, I know Jan is getting anxious already. Please don't turn off my microphone. So, it's not only the technical thing, it's about people, it's about governance, communication, institutions. And if you want to be successful, you have to have a good infrastructure in place, clear rules, and you have to put effort into the training. And you saw in my presentation what is really possible with this implementation, what to be aware of, don't do the same mistake, but most important, only thing that matters in my presentation, you can forget everything else I talked about. Don't overthink this thing, just start, or as it was in Jan's slide, just do it. And thank you very much. And as I see, there are like so many microphones here, so and Jan does not allow any kind of questions, then maybe I can drop the mic. Okay, just kidding. Thank you.
Thank you, Chris. So you managed to keep on time. Wonderful. That's what the applause was for. No, good. I think it's really interesting to hear the experience from Estonia. And yeah, it is true. I kind of ditched out the door when you started really implementing. So I did the fun part, and then, oops, I'm not here anymore. But it's a good story, and I think there's a lot to learn. But I like your message of just starting.
No, Jan, we have the fun part. Implementing is also a lot of fun.
It is, but starting things is always more exciting, you know. But it's the hard part, and it takes time. But we're getting there, and I see there's so much more others who are getting in on the game and also working hard at it. And if you want to learn more about it, many of you have already signed up for the workshop we're doing with Chris tomorrow. And the seats are full, but if you really want to, maybe we
just break in.
We can find an extra chair, and it's not just us in the workshop. I'm really happy Pia is going to be there from Solid. No, but you were signed up. Come on, I've been telling everybody you're coming. Now you have to come. She's busy. Well, we'll get some insights from her anyway, and she has a presentation later on. No, not you, but your colleague from Solid. Okay, I'm doing previews for the next session in the evening. Right now you're hungry. You want to go to lunch. So let's all break for lunch, and we meet back in a little bit, in less than an hour. So that would be 13:45 here. So listen to the wonderful music of Strauss. Thank you.
So I'm very happy to introduce our next speaker. We will have on stage a representative of our gold sponsor, ACCA. Probably every one of you knows ACCA. And I want to introduce to you Alfonso Perna, who is focusing on deploying openBIM standards through European countries and beyond. So thank you for being here, and Alfonso, the stage is yours.
Thank you for your introduction. It's a pleasure for me today to introduce you to this success case, which is an experimentation we had with ANAS in Italy regarding the use of IDS and BSDD mainly. So how we build the solution for the customer? The solution is built on the architecture of modules we have inside our platform, where you have the light-colored one, which are free of charge services, and all the other services are other specific modules processing the information, and that makes possible the platform to be aligned with the requirements of the customer. So you can recognize the IDS module, the BSDD module, and as well the editing module. Our platform, so is a common data environment. We can go on, I would say, internet kind of deployment, cloud deployments, or come on-premise inside your data centers. Of course, we are compliant in terms of security with the ISO 27001 and compliant with the ISO 19650, which is the regulation, the recommendation in Europe when you go on tenderings with the BIM obligations. At the base here, you can recognize all the logos of the standards that we are pushing forward, which are the standards from Building Smart International. I will go in more details in the next slides. So, IDS, I suppose that many of you are familiar with this kind of standards, which is a kind of machine-readable list of rules that we can run on a system to check the quality of the level of information when we are publishing, uploading models inside a common data environment. This is a really important thing because consider that the first bad experiences we have using common data environments with organization, government agencies is that a lot of time these models are not properly enriched of the information that is necessary. So just here I've taken a small trunk of a railway. We are working with IDS on what it's called facets, and we can specify requirements on these modules. This is the facet. So I go forward, and now I introduce you this experience we had with this strong, big organization in Italy, which is ANAS. ANAS now is part of the main group managing in Italy all the railway infrastructure and the road infrastructure. We have as a partner Bonifica in this project, and what we have produced for them. We started analyzing kind of requirements they used to work with that were at that time Excel files mainly, and the situation was really complicated. They had as well PDF file. The problem was for ANAS to understand how they can translate in this list of rules the requirements, the level of details and other facets kind of requirements. So typically what you are seeing here, there now on the screen are the files they were using, and the files we started our surveys in trying to find the best way to make possible for them to use the EDS standard. So of course we had a lot of requirements. Consider that the organization is working on about 20,000 kilometers of roads in different regions. So we built for them a first tool that makes possible to create from the Excel file the list of requirements, specific IDS kind of rules. So as you can see in this example, we specialized a kind of batch procedure where they just uploaded the XLS specifications and they can produce the list of rules you have to check when you upload information inside these working spaces for the organization. One of the criteria was as well the work, the WBS kind of data. So thanks to this input from the organization, we produced this list of requirements, and the application was divided in 3 phases. The first one is the creator, we have just seen together. The second phase now we are looking here in this second part of this video is the part of the modeler. So what the modeler is typically doing. Is working maybe with Navisworks, is working with Revit, Allplan, Vectorworks, or other kind of, I would say, authoring tools. And he can here use the IFC file is exporting with the IDS requirement you see on the left side, and he can test the compliance of these files, thanks as well a BSDD structure. So let's see together how the system works. So the first step is to take an IFC file on the system and to upload this model inside the platform. As you can see, it's a trunk of a bridge here. The second phase is to select the IDS regulations list to check against this model. So I choose the IDS list of rules, and automatically the system creates in this kind of tool a WBS kind of structure that is more familiar in the industry of the roads in Italy in this case. And thanks to this system, we can see that we have already one interesting thing. The system is suggesting to the authoring user here, who exported the IFC, with the red colors, some different attributes, properties that are missing in the model. Of course, we are using the BSDD dictionary to help, in this case, the customer to maybe insert the proper enumerated type of elements. In this case, so you can see that we have a tool that makes easy for the modeler to go through different kind of fixes that he can manage on its own just using a Chrome navigation system. In this case, we are as well using the Uniclass property that is linked to the BSDD. So the BSDD, I think many of you are familiar as well with the Building Smart Data Dictionary, which is the structure. And you can so have an idea of this tool that can give you this kind of selective view. You can just check the criteria where you want to check the model, and the system will synchronize what you see on the left side about the graphical property. Of course, one important detail, the IDS properties we are checking are not graphical one. So this is, in this particular success case, we used here IFC 2.3 and 4.3 models. So when the modeler finished his checking, he just uploaded these files to the organization, to the validator. So probably you are more guys working in this kind of area. Here you can see that as an organization, I have an automatizations in terms of control of all the IFC file which will be uploaded in my platform. So for this kind now of checking, we are in the room of the authority accepting these files. And the system is working, you will see, in a quite a different way. We have improved as well. This kind of tool now is working with different IDS rule sets, is a kind of agentic kind of tool. And you can see here in this example that we are checking a federated kind of context of 5 kilometers, where different models has been uploaded, and where now we will run a test on all these. I think we have about 50 different models inside this federation. As you can see, unfortunately, we have a lot of problems that are reported here that are not in compliance with my IDS rule. When I select one element, I can go on the details and understand what is not compliant very easily. And I have all a different kind of tools to have a better picture of what is going wrong with this file in terms of validation. Just an important information, this project was in the year 2021 awarded as a best project for Building Smart International. So as you can see there, we can, with these pies, understand what kind of problems are emerging from these uploads. And so by clicking on the slides, on the slice, I can see where the graphical parts are not compliant with my criteria. What is, in terms of technology, what is important from this success case is that you have in one service the possibility to check against rule set and as well to fix problems. You don't need this file to go around to be versioned again, exported, but you can use your IFC file here to fix all the kind of problems. Oh, I have to go quickly, so I pass to the last part of my presentation, where I want to give you the idea on what is the value of good IFC models when you got them on your platform. So take here a portfolio of IFC file. This is probably an agency in charge for energy efficiency in a city, okay? When, in this case, I am extending all the IFC on the scale of a GIS system. We are inside Esri ArcGIS 3D. So as you can see, I'm using here a lot of information, good semantics, I have inside my IFC models to create literally kind of queries on the fly. So I don't have to pre-process information or to synchronize the information with the 3D models. Everything is available on the file, so you have the consistency of the 3D models and the capacity to go through geodata. So we can build easily a kind of dashboard like this one if in my models I have all the energy efficiency details. So if I want to check for this building, if it's true that the assessment is the green one, I have the document which is attached inside my common data environment. Following this approach, you will never have artificial intelligence working on bad information. In this case, if I have checked the information about my portfolio of IFC files, I can build in a time for our developers, I think something about 1 hour work, and you can use, in this case, an LLM tool to ask the system, can you give me a plot of the destination of views of these flats, these buildings? The system can give you this answer. I can ask the system, please, let me know where are the bathrooms. And I can have this kind of synchronization based on the consistency of the 3D view and the good information that can be kept inside your IFC files. So I can ask the system, where is the largest bathroom? And how you can see here, the system can give me the right answer. So thank you for your time, and maybe we can have some questions, or I'm short of time. Thank you.
So thank you very much, Alfonso. It's always good if the audience is taking photographs and clicking all through your presentation. So I think one or two quick, you remind me of yesterday, quick questions or short questions. So is there any urgent question? No? Then otherwise you will be available today, I guess?
Of course, of course.
Of course, and tomorrow as well. So Thank you very much.
Thank you again.
Just a little. So, sorry, it's me again. Who was laughing? So, I'm Adrian. I'm taking over from Judith because of her voice, so bear with me. We have a lot of interesting presentations, and especially with very long titles again. So we start with Beyond Binary Compliance, Mapping Hybrid Rule Logics for Logic-Aware Digitalization of Building Codes. So off you go.
Thank you very much. Can I get a microphone? Then I'm not bound by technology, so that's good. Thank you very much. The presentation today, just to follow up from the previous presentation, I also will start out by talking to your feelings, as we did earlier with the presentation of in Madrid and how they used Roadrunner and Zootopia to talk about feelings and building permits. So, but this study was a collaboration together with Judith Fout and my colleague from University College of Northern Denmark and Mohammed Munib from also Technical University of Munich. And me, Peter Nørkagade, I'm head of research and docent at the University College of Northern Denmark. So I'm not using Roadrunner this time, but instead I'm using a piece of art or art project. I'm not know if you are aware of it, but it's an interesting piece of art made by Song Wen Chung, a Chinese-Canadian English artist who experiments with technology and art, or design you could say, about the interrelationship of those two. The reason why I take it is that basically this presentation, what it tries to do is that it tries to question, we increasingly, and what this conference is about, we try to formalize building law into machine-readable formats, for example. And then sometimes there's a danger that we can treat digital tools as neutral and binary constraints. But in reality, it's often not the case. And there's a danger that we can lose interpretive contextual elements and also what we would define as epistemic distortion, and that will result in poor design outcomes. Back in the days, one of the first artists who used algorithms to produce art was a German guy called Manfred Mohr. He used algorithms to create art like this. He had a very old school way of looking at technology that we need to, in a way, distance ourselves from. This idea that we use algorithm directly as a tool to create art, but often the case is, for example, how we use digital tools in the construction industry, in a way, is a co-design between the systems, Revit, for example, that we use, or the compliance systems, in order to create the design. So what I'll be presenting today is looking into the ambiguity of rules, contextual rules, how it's translated into rigid thresholds, how it can result in loss of professional discretion, reduced design flexibility, and drift from the original regulatory intent. So the research question is, how are different types of regulatory logic embedded in building code rule spaces, and what implications does this hold for the digitalization of regulatory interpretation and compliance? So the way we started to look at this was trying to do a conceptual framing of what is a rule and how do we treat a rule in a sense. So we did this by defining what we defined as a rule space. So basically, all rules has a bounded interpretive domain. You can interpret a rule that is okay, and you can interpret a rule the wrong way. We can agree on that. So basically, there's a boundary, and this boundary is shaped by language, intent, and context. So of course, you have a rule that has an intent. We want fire safety, and we want fire safety in specific contexts. And how we achieve that in many different building regulations can differ. For example, in many building codes, especially one in Denmark, it's highly defined by performance or funktion, as we call it in Danish. This means that there are many different ways that we can achieve that function in buildings, for example. Often it requires, not often, most of the cases, it requires professional judgment to navigate this. And this also argues that there's different ways to achieving this, and that is often done by professional judgment. Some theorists in legal theory talk about then a rule only is understood in the context where it is interpreted in a sense. And here we have a digital danger that we can distance ourselves from that interpretation. So the way we looked at this, trying to understand the rule space, the intent, the context, and the boundaries of its application, we defined to set out a set of logics to try to understand this. We know the formal logic, of course, so this has a key trait of binary truth values, rules as they are exactly written. One example is this: if a staircase exceeds 4 meters, it must have a handrail, and so forth. We know this. Then we have the technical logic that requires some technical expertise or references that, for example, also can be performance-based, that you need to look into different standards and do calculations or simulations to achieve this. We have interpretive logics. I know it has a bad reputation, the ambiguity, the interpretation stuff of things. So often we see, for example, in the Danish building regulations, there's a lot of ambiguity embedded in that. So, for example, buildings must have safe access to emergency responders. A lot of engineers in Denmark hate this one, because what constitutes as safe access in a sense? Of course, we have guidance documentation to help assess these things, but under the law, there's many different ways of obtaining this. And then, of course, we also have some fuzzy logic to also denominate another kind of logic. So, just not to spend too much time on this, the way we dealt with this was not only by looking at the building codes as they would be framed in the Danish building regulation, for example. So what we did instead was, in Denmark, there's an open data set that is based on how a municipality in Copenhagen have interpreted the building regulations in Denmark. So here, actually, they took more than you could say the building code. They interpreted it in the municipality of Copenhagen. And based on this 143 different questions that were selected out to represent the width of the Danish building regulation, we tried to look into how the different types of logics were located in these questions. So we did this by doing a qualitative coding of linguistic markers, where rules were manually coded, and then we had like a refinement process of that to ensure that the OR interpretation of that was the best. This is an example on how this was done. There's a small issue here. You can see they're missing 2 colors. You can guess that this is a yellow color, red color. And this is a yellow color missing, sorry for that. But basically what we have done is looking through the questions and answers, looking for the different types of logic according to the 143 questions, and took out snippets of text that would relate to the different types of logic. So what we found in these 143 questions, 138 of them contained formal legal logic, a good thing, would many people say. And that is 96.5%. Technical functional logic, 63.6%. Interpretive practical logic, 44.8%. And fuzzy logic in 21.7%. However, what we found out was that only 27% of the rules relied on one type of logic based on this. 2 logic combination was the largest groups of logics with 60 rules. Trilogic hybrids appeared in 33 rules, that's 23.1%, and full quadruple hybrids emerged in 19 cases, representing 13.3%. So basically what we see is that these kinds of rule set interpreted building codes has this composite rationality in a sense. And also could argue for what is this an expression for. So we see this in a sense as a deliberate balancing between determination and flexibility. And also that these quadruple hybrids reveal an ambition of integrate binary thresholds, performance targets, discretionary judgment, and graded membership within single clauses. So our thing is that, how does these building codes embed hybrid logics? How can we do this the good way? Because there is a danger, as we sometimes also see, at this over ambition to reduce, simplify logic in a sense that was not the original intent. In Denmark, it has been a clear intent to embed vagueness, for example, and ambiguity to highlight that there are many ways that could be legal in specific cases of achieving compliance to a code. And when we reduce that, it can either be reduced in a legal form at the building codes, but it can also be reduced in the process of trying to digitalize it. I think the most important thing is that we are transparent about it, and it's deliberate how we do this flattening in a sense. Because there's this danger that it can distort regulatory intent. And as I see it, we still have some issues about how we can best possibly deal with this multi-logical structure in how we digitalize these things, so we don't end up with something that is overly binary in that sense. So what we are looking into is trying to develop these logic-aware compliance tools, ensure schematic transparency, and very important audiability, so we can see how things were interpreted. Also, try to look more into, for example, these interpretive rules. Maybe it's not a matter of automating, but it's about laying out information for people to make the best possible judgment. We are looking into scaling and this analysis with NLP-assisted pre-labeling and explore hybrid computational architectures and trying to evaluate workflow impact on practitioners. Thank you very much.
So thank you very much. I don't want to be a killjoy every time when I come around with the red flag, sorry. Are there any questions? Everybody's overwhelmed, and I was looking, everybody was photographing your slides, so that's a good sign.
Very good.
So if there are no questions, I think there was one.
Thank you for the presentation and the different and showing us the different logics in the rules. Do you have then also decided to use different programming languages for the different logics?
It's a very good question. What we have been looking into is, one of the things we are going to look into is not necessarily programming language. Now we have the language models now are all the hype, but we are very unaware about how the different language models respond to different kinds of logic, because we have a hunch it's not the same. But the same thing as the programming language. These, again, are not neutral systems. And I think it's very important for us to be aware about these types of systems have some kind of, you could say, hidden logic behind that could favor something or process something better or more intentional than others. Yeah. Thank you.
The different programming languages or different languages are not consistent. For instance, I had a problem, which I just coming out a paper, how to combine description logic with fuzzy logic. It's a nice, interesting topic.
It's a very interesting topic. I don't have the solution yet, but maybe later on.
Yet.
So yeah, we are optimistic.
You have one day more till tomorrow.
Yeah.
So, thank you very much.
Thank you very much.
So we are heading over to, I think Marcus is presenting about the concept for modeling uncertainty in regulations in the context of BIM-based building permits. Do you want the hand free or just,
Sorry for the long title. So hello everyone. Thank you for the presentation. So we are also dealing with these uncertainties, vagueness, and all these other problems we have in the regulations. Today I'm very happy to present some of our first ideas or results. So it's not my idea, it's the idea of my PhD student, Hannah. So I will present her ideas for her PhD in the future. So I think I need something to somewhere, I don't know. Okay, thank you very much. So I can try to remember all the slides, but it's quite complicated for me because these are not my slides. So I think I don't have to talk about the current status anymore. You had this yesterday, we have this morning and everywhere. So the biggest problem, of course, is not really checking of the model if everything is inside, checking against the rules. So we have a model, we have information on the drawings, are they compliant? Or how we can check this, and of course, therefore we need rules, and therefore we need somehow the rules more in a machine-readable way, and this is the main challenge, of course. So I don't want to focus a lot on that. So maybe also yesterday you heard about some of our projects running in Germany. So we are working at the moment developing these rules. This is a manual process. So you go through the regulation, through the building codes, write it down, write requirements, information requirements, what you have to put into your model. For example, you're coming out with modeling guidelines, and maybe then, unfortunately it's in German, most of the content, but maybe you can read it a little bit. So we have different paragraphs in the codes, and then there's a manual way translating these codes into rules, into machine-readable rules, and best would be, of course, that we can check these rules afterwards. So we did this in Germany for many building codes in different states, also on the city level, and we developed some of these modeling guidelines. So I think the procedure is always like this. So you start with the standards, you categorize a little bit the standards, what you can check, machine readable, translate it into the logic, say it's less than, bigger than, or whatever. And then, of course, at the moment we are skipping all the vague terms. So we said, okay, we cannot handle this with a computer. It's not 0 or 1. It's not possible for us now to check it. So therefore we have a manual check. Then we came to the rule base, say, okay, we store all the rules. Then we have, of course, the model based on our modeling guidelines. We do the checking. We can have annotations. We have a feedback to the architects and so on. We use the standards we all know. And then, of course, we have some kind of maybe a decision graph where we say, okay, this decision is made by this rule because you fulfill something, so this threshold is not reached or the distance is correct or whatever. So this is, of course, hopefully our future, maybe, hopefully tomorrow. But of course, we have now to deal a little bit with the other terms, with the other aspects which we have in our code. So that means we have this text-based documentation, we have some written text, understandable by the human. Maybe we interpret the text a little bit, always a little bit different. We had also the problem where we thought it's very accurate, described, but if you're talking with 2 or 3 people from the authorities, they say, okay, in my case, I would say we can also use this or that, or maybe it's not really that fixed, this limit. So there we can always interpret a little bit the rules, and of course, this is also nice. So this is sometimes also the intention that we not have everything fixed, that we have the option to integrate new ideas. So it's a little bit performance-based checking, so we have just to fulfill a certain criteria. So we have a lot of regulations everywhere, and so now we have to think about how we maybe can categorize. So it's very, very good work. I don't have to add anything. We have not so many categories. So we all distinguish between terms which we can really model, like this deterministic requirements which we can check, and we have maybe non-deterministic requirements. Maybe they are vague or they are a little bit more descriptive than the others. So we categorize this in these 3 aspects, and now we have to think of course, how we can maybe deal with these more vague terms. And of course, I'm a computer scientist. I'm always thinking about how can I do the implementation and maybe the checking and how we can extend this. So here are also some examples. So where we say we have some, it's hard for me to read. I need a new glasses, I would say. So it's a little bit about the general information. So we have some terms like shall, it should, or we have some deviations we can have, maybe that we have some alternatives which we can check, or maybe this is really vague, how we can deal and handle this. So everybody can maybe read, and maybe you find in every code something like this. It's more or less. So of course we are always saying, okay, let's start. And I saw also fuzzy on your slide. So the first idea was, of course, because we need something for a PhD, it should be a little bit more fancy. Maybe why not testing it out to maybe apply fuzzy logic or fuzzy numbers. These numbers express not the term is not a logic like only true or false. It can be something in the middle. So we have a so-called membership function where we say we fulfill this to a certain degree. So the biggest issue, of course, is to define this membership function in a correct way. So we also started with maybe some easier terms like insulation. Maybe it should be a good insulation. What does it mean? So then we can concentrate, of course, on the U value, for example. The U value should be in a certain range. Of course, you can also use ranges. But if you want to express this vagueness a little bit better, so a good concept is fuzzy logic in this case. And you can also calculate and do some reasoning and so on by using these numbers, these fuzzy numbers. So it's a little bit, you're not dealing with one number, you're dealing with the function and bring it together. So therefore we are now trying to identify some of these rules and to express this in a certain way that we have a fuzzy membership function in the end, and then we can aggregate and also check it, of course. However, we have to do this definition. So it's really not easy to find a good membership function for a certain aspect, and therefore we need a lot of expert knowledge. So this is one thing we are working on. We have some results. We're testing out some system, also implementing this. The other thing is a little bit about things where you have some options. So it's not really fixed. There's a fixed solution. We say, okay, the authority can handle this always a little bit in a different way. You have maybe a checking, predefined rule where you check it's not satisfied, but there can be another option to have the same result. So it's a little bit this performance-based regulation. And here we think very important is really to store this down in a certain way that we say, okay, we're covering this knowledge from the authorities, that they say, in this, it's not really fulfilled, but you have a compensation, for example, you have a good idea to maybe deal with some aspects about fire safety or whatever, document this in a way that I can follow it maybe afterwards, that I say, okay, for the next checking, I consider this knowledge, what we did before, in the next checking procedure, that we're not always defining. So this is a knowledge base which are more or less is living and it's always growing from project to project. And therefore we think graph-based solutions are very good. Oh, I have to speed up a lot. It's very, very important. So I'm a professor, sorry for that, so I'm always talking a little bit longer. Therefore we think decision graphs are very good for this concept, to say, okay, we really model all the decisions in the graph, and we can also use this graph later on to search for similarities in another project to take it over. So this is more or less our idea. We have also semantic annotation and of course this documentation. So there's one arrow missing, so we have the fuzzy vagueness terms, for example, using fuzzy logic, bringing this into the rule database, and when doing the checking, we do the documentation and store it also in the rule database. There should be also a arrow backed into the rule database. So this is our first idea, and I don't want to conclude this because it's so short. So the conclusion, of course, we are working on that. So a lot of terms are in our regulations, and of course, we are just integrating, or we are implementing this now in BIM checking systems to integrate in the first step our fuzzy membership functions. Thank you very much.
That was quick, that was fancy, but not fussy. So thank you very much. I think one question, Nick. So I haven't done my 10,000 steps today. So.
Okay.
This applies to Peter's talk as well.
Yeah.
I think we're in danger of mixing sentences that define objectives with sentences that define metrics.
Yeah.
If I say to my child, you mustn't get wet, you must wear a coat, how can the child obey the first rule? He can't.
Yeah.
He can only obey the second rule, you must take a coat. And legislation is written with objectives and then metrics. And I thought in your case, the fact that the sentences were being mixed in clauses was because every time it's an objective, then followed by a metric. And so we mustn't be computer scientists. We must be literate human beings and read the documents not sentence by sentence, but as if they were works of literature with meaning and sense. And not assume that just because we don't understand them, they're nonsense. That's, buildings are being passed and checked. So these regulations must mean something, because otherwise there'll be no building happening outside.
Yeah, of course, first of all, you're right. So my intention is not to make it everything black and white. So this is, of course, one thing we also recognize during all these projects, that we say, okay, sometimes it's really good that we have an intention, an objective, and then we discuss together a solution and provide this solution. So of course, we also want to speed up the process a little bit. Therefore, it would be good, maybe sometimes we have to maybe reformulate also regulations. It is getting better checkable or more machine readable and so on. So I think there are always parts. And we also think maybe 60% we can maybe check, maybe 20% we can have this vagueness also a little bit with checking, maybe 20 or 30% is just we have to work together. But therefore we need time, and therefore we need to identify especially what we can automate a little bit better. So, but it's a discussion. So we're sitting together with all these experts, and I totally understand. I'm a computer scientist. I want to have 0 and 1, of course, in the end.
So thank you very much. Good luck with that. So thank you very much. And we are going to Sarah, talking about the definition of information requirements for the semi-automation of building height compliance checking in Italian municipalities. So that's quite a mouthful. Looking forward to your presentation. You have the clicker, Marcus, to your left? Okay,
yes.
Good.
Okay, thank you very much. I'm Sarah Comai. I speak. Okay, perfect. Thank you. I'm Sarah Comai. I work for the University of Brescia, and today I tell you about our research with the title Definition of Information Requirement for the Semi-Automation of Building Height Compliance Checking in Italian Municipality. For several years now, the European Commission has been focusing in the digitalization of the construction sector. It began with a strategy related to the dual green and digital translation of the construction ecosystem in 2020. And After that, in 2023, want to focus on the machine-readable format to automate the compliance checks. And last year, share a document contain a lot of information for the digitalization of building permits to promote the transparency, the regulatory compliance, and to promote efficient collaboration. The building permit, there are 4 pillars for the building permit, and this work is including simple and machine-readable rules and requirements. So, in recent years, research has focused on the interaction between the BIM and the GIS, and okay, and the researcher has recognized the importance of the interaction between these two environments, between the building model and its context. And in building permit, these two environments cannot be considered separately, but must be related to each other in order to provide complete information. So this work, there are 2 main questions to develop this work. The first is, are the current digital design models and regulatory documents complete and unambiguous enough to support automated height check? And the second is, what instruments are needed in both design best practices and regulatory writing to enable a reliable digital check compliance process? And this work want to present a methodology to support the semi-automation of the definition of the information requirement to automate the compliance check of the maximum building height. So there are 3 main steps. The first is the regulatory analysis of definition and definition of information requirement, and after the collection of the legal document. The second is data modeling in GeoBIM environment. And the third is the assessment of information requirement completeness for building height check. In the Ascoli Piceno municipality in Italy, there are 2 main regulations. The first is the building regulation that contain all the definition of the element of the building. And in the technical implementation regulation, there are a lot of constraints that can be observed in the design phase. We identify the useful normative article, and we translate it in English. And we validate the translation with a municipal expert to avoid the translation errors. And we identify with a manual semantic analysis the terms for defined information requirement, for example, elevation or building in the slide. And we identified the expression that must be analyzed in the detail, for example, ground line and roof line. After that, we must structure and map this information requirement in 2 different environments. We identify the building element and the context element. So for the entity and property related to the building, we use the IFC version 4 Addendum 2 TC1, and for the context element, we use the CTGML, CTJSON, and Inspire standard. And for GeoBIM Vision, to automate the building height check, we must isolate the skin of the building, and we convert some geometry from GIS to BIM with a converter. And we can try to analyze the height of the building, but there are three very important things to identify. The first, the identification of the main facade, and the second is the base point, and the third is the end point to calculate the height. And the building is composed by 4 or more facades. So to identify the main facade, we propose some solution, and we decided to add a property in an entrance door, and the property is a main entrance. And for identify the base point, we don't have any problem, because the intersection between the facade and the sidewalk or terrain. And to identify the end point, we must add another property. In particular, we must identify the structural part of the roof, and we need add is a structural property in the structural layer of the roof. So here is the summary of the entity and property that we define to automate this check. And we include all information requirement from the legal document or from this reasoning. And all these entity property must discuss with the municipal access and the design. So the conclusion, the result showed that the initial information requirement from the legal document were not sufficient to clearly identify the main facade, the end point, and there is a misalignment between the regulatory text and the structural information to automate all these process, and is very important enrichment the model with semantic properties and annotation, and is very important to restructure the normative article, introducing the controlled language, controlled vocabularies, and formal definition to support information requirement definition. And now we apply on the building height check, but is need to apply to the other types of check included in the municipality regulation. So thank you very much, and thank you to Siam, Francesca, Leontine, and Silvia.
Thank you very much, Sarah. You just had 30 seconds left, so you would have had time. So, but we put that on the question part of this presentation. Are there any questions? No, you explained it so well. So thank you very much, Sarah.
Thank you very much.
So, and now we need the next presentation. Constantine, I count on you. Perfect. So, last but not least, we go to Elif, talking about interpreting performance-based requirements by use of legal reasoning. Stage is yours.
Thank you. I'm a bit sure. I see the presentation like made of me, but the audience doesn't like what I'm used to. This is what I normally have when I am talking about what we develop of large language models at NTNU. Because I have been at all that the community for compliance checking was that small that it was enough on the first row. So something has happened. There has been a significant development. I can confirm that being so old in this industry. I have foresee a long practice from a lot of parts. I also worked at the building authority. But when I asked the question, I said, why do we need a building application? Couldn't we develop a project management system that could tell you, now we have enough information to give you the permit, now we have enough information to give you a loan, and now we have all this information. So that's why I switched over to the university and project management. More about that, working with a lot of stuff. I can explain the title for you because I do think it's a lot of strange word. First, it's interpreting. Have you heard about it, that you have to interpret something? Bad word. Performance-based requirements. Prescriptive, I know that you have heard about, but this is something odd. But it exists a lot. And it also was confirmed by some of the other presenters that said that 80% was of these types of performance-based, and only 20% was on the prescriptive. By use, I know that, you know that. Things that can be used, you are very focused on. And then I come up with a new discipline called legal reasoning. Have you heard about that? Legal reasoning. This is also my background because I also worked some year at legal informatics, and then I was the lucky guy who had quite a nice domain of legalization, and quite and very not that complicated compared to what the other professor was doing at that time. More about that. This is what the question is. Legal engineering toolbox. That's a word you like. For engineers. Which do you have? What do you have in your toolbox? Nick, you are not allowed to say race, because I'm talking about the tools you are using before you are going into the race machine that do all the rules and make it very clear. Take it from lines to tables. Do we have any toolbox for engineers? I know that, as I said, you could study legal informatics. It takes only 5 years and some more years to practice. That's why I take up that there exists some toolbox. So if you know that, you can look for them, search for them, and if you don't find them on the internet, you can talk to me because I've been in this business. So there is someone, and of course all of those has a 3-letter abbreviation. But before we start that, we also have to understand the legalization. And also what you can do when you are taking a general rule to make it used in a specific case. And here you see that you have 3 letters. You have the legalization as the context around it. This is the law. And then you can go more and more into detail about some constraints, and also you end up with the context that you actually is going to use in this case. And that has to be, by principle, narrower than what is possible in a specific case that can be used. So being that this is showing the pragmatic approach, you are not having a digital rules, a digital checking to check all possible context, all possible constraints. You take the safe one where you know that you are beyond the border of the law. That's the purpose of it. If it's on odd cases, then you have to do it. So that is the background. So if you accept that, some of you should not accept it because you do think that you should have a digital rule that covers everything, but this is the pragmatic approach. Then we have some tool. And then you see, based on this classification tool, and we like to also have 3-letter abbreviation, transcribe, transform, and transfer. And it's quite simple. If it's a clear rule, turning circle 1,500 millimeter. Yes, just put it into race and you get all those requirements in a very clear form, very clear tables, easy for them to program. Then you have the other side, transfer. It's so complicated, so the context is so divided that it takes so much resources to develop digital rule that can fit in those extreme conditions. So then we see that, okay, you do that manual. But you can know those requirements in advance. And then we have the large group, the transform, the one that you can interpret by a joint understanding. An example for it here, you see, I'm not going into detail, but you see that you have in this example, the standard for accessibility, who should be very precise. You expect that it's a measurement, and people that having access to different parts of the building, you see that 57% is okay. That's clear rules. Turning circles, slope, degrees, and so on. Then you have some rules that you take, is very blurry. It should be this and it's nice. But you have then again a group of 26. That, yes, in some cases I can see that it's possible to put a number. Because in this standard, the human being was a measurement of everything. And then you know that when you're sitting in a wheelchair, is 60 years old, how much can you lift? There is tables for that by medical departments and so on. So it is possible to see that this is too high. 15 kilograms and lifting that too high. 5 is maybe okay. You have also some rules, but that's also a way. And then I have developed a way to make those qualitative or prescriptive requirements and the hard one to mix together by test indicator objective. It's a way to negotiate into a compromise. And you see that, okay, you can make those rules as that according to those, we have interpreted that. Close to parking, okay, we have it less than 30 meters. If you disagree, okay, that's the stuff, but you can then, in a digital system, in your context, say that, okay, 40 meters for this type of users, then it's agreed, then you can test about it. But you have measured the distance. Then you see, when you combine this, you get a digital system where 87% is possible to get a feedback from a digital solution. Then it's helping you in the design process. You can get the answer, feedback on it. You can go back on it. And then you see it's only 17% that maybe is not relevant for you. But then you see that you have a system that is helpful. And I do think that that is missing in some cases because we do think that, okay, it should be possible to have 100% automatic. When you are working with legal informatics and talking about 100% automatic, they just laugh at you. That is not possible. It's not possible because we have developed a lot of it in Norway about tax, but we don't take all cases. We take the most used one, and then we cover up to take more and more. So we see at this system, it's helpful. You can discuss it, you can do it. You can also see what is close distance, because what are you going to do with the performance of it. So it's not having this fist, it's helping you to get a better design and also interpret and understand the regulation. Then also we can go into more advanced methods with legal reasoning, also about fairness, accountability, transparency. Again, it's the same principles that you know the metrics behind the reason behind the metrics that you have put up. Then you can have a dialogue about it, what's relevant in this context. Because you do think that is also always the purpose with the regulation that you have to fulfill. As in Norway, it should be safe and for fire, so you don't die in the building. That's not nice. And you should not use too much energy. And of course, if it's a public building, most people should be able to use it. That's the principles. And then you interpret it. And from a legal science, that's the way you interpret law. But when you come to engineering, we don't like this word interpreting. So that is saying something about it. What I'm ending up with now, and don't read all the text, but I do think it is possible to expand the number of requirements that we can put into a digital solution by having this approach. The examples that I have showed that it is possible, and also for systematic use, also based on some tools, because you cannot expect that everyone should study legal informatics, but there are some tools that giving you closer. And then also you can see coming more into that use. So it's a very, very pragmatic approach that is behind it. Yes, in most cases you can see you are far behind. It's okay. Don't have to go into the borders. And there, I take the last slide, where I also do think that we have to rethink what we do think about automatic compliance, and also this checking where you see that the last one can stop both for a companion, also it's helping you to understand the rules, the impact of the rules, that is not often very consequent. And also, you can also see that in this case, it is in compliance. Yes, that was my message from the legal informatics side, and also as an old bloke in this community. And I do think that we can increase the number of cases, and by this, get more resources to what we are doing. Because when you say that you only can check 6%, and the rest of it, you don't want, but we can say 83%, I do think that you get more funding and more attention. Thank you.
Thank you very much. More funding sounds always good. So, any questions? No? Ah, there, sorry. I'm not used to looking the first one. Oh,
thank you very much. I live very interesting. Regarding the, you could say, the transfer part of TIO, for the judgment part of things, inspired by a legal side of digitalization, have you thought about any expansion in that direction on how could that part be digitalized?
I think it's open for a dialogue and argument, and that based on your argument, based on the purpose with that, then you have the dialogue. And I do think that opens also for different types of logic.
Now we reach the final session of the second day. This is the only session which separates us from the dinner in the major city hall. Everyone is waiting for, but actually you're waiting for the final talks. And the first one will be from one of our main sponsors, Anul, but they're not only a sponsor, they have been a long-term partner also of our university, helping us teaching the right software, I guess. And we heard already from Roman Schneider before about Prise Vienna and the following, this digital building permitting system, and Anul will present his use case, how it worked for them. So come to stage, Thomas. And Matthias.
Thank you very much. Welcome back from coffee break. Before we start to talk about our experiences with the Prise project, a few quick words about who we are. This is my colleague, Thomas Böck, and I'm Matthias Stadler, and we both are trainers and consultants at Anul Bausoftware, and we are also certified trainers from the Building Smart Austria. We are part of a rather big team at Anul Bausoftware. We are about 40 people, a little bit more. And our main clients are in the construction industry. So they reach from architects to construction works and to public clients. We have three big business sectors in our company. The first one is software. We are the biggest seller of Archicad in Austria, and we also sell Solibri, BIM Collab, you name it. The second part is the training program. We have more than 40 courses. You can visit them in-house in Vienna, Austria, or Ulm and Berlin, Germany. You can also join them online, so from wherever you want. And we are e-learning wherever and whenever you want. The third part is our consulting part, where we support our clients in software or BIM coordination and some special consultings like the Prise project, which Thomas is talking about right now.
Thank you. Yeah, our experience with the DPP is about the research project Prise back in 2022. We have had the privilege to support 4 of our clients with the process. There were Architekten Soika Silva Soika, Boldorf-Architekten, Hoppe-Partner-Architekten und Kurz-Architekten. If you want to talk to them, they are here today. From Soika Sivasoika, Pyrosnia is sitting right in the middle. Von Boldorf-Architekten, Sophie Boldorf herself, and von Kurz-Architekten, Wolfgang Kurz. Yeah, so they are willingly to talk to everybody. The permissions were 3 residential buildings and 1 office building. The office building is Go 19 from Soika Sivasoika, you see in the picture. And of course, there were some challenges. I won't go into detail, but the main challenges were like, of course, the BIM and software know-how. If you never needed to export an IFC file, you had to learn this kind of thing. And then the amount of information you had to put in your model itself. First of all, you had to create the space where to put the information, and then to put in the information itself. With the first part, we could help from the software side, and the second part, the architects had to do it themselves. And then, of course, you had to check if the information you put in is correct. Back in 2022, there were no IDS files. So the pre-check mentioned by Roman Schneider before was crucial in this part. So the architects could check the quality of the models before they submitted them. And then there was some modeling guidelines, not necessarily needed for your daily work, something like the load-bearing layer of the roof needed to be separated, modeled, and some additional volumes just for the checking by the authority of the city of Vienna, like a volume for dorms, and so on. So these were the main challenges they faced, and we successfully helped them with their experience. And we are very happy and proud that their models were among the best that submitted. There were 13 submissions in total, I think, and 4 we... yeah, okay, thank you.
Quick check with Roman Schneider. Thank you.
And 4 of them we happily were able to help. Yeah. The other question is, why would somebody do that? Why would you face these challenges? Of course, there are opportunities. The potential for this innovative submission method, first of all. Then the preparation for the future, for future developments. The next time it's easier. Then the prospect of faster project approval is a win for everyone. And of course, the experience you gained can be transferred to other BIM projects as well. Yeah, a lot changed since then. And on the technology part, Matthias will talk a little bit.
Yes, you heard, since 2022, something changed. We now have IDS. IDS is Information Delivery Specifications. I think everyone knows about it. There are some key facts. It's an openBIM standard from the Building Smart International, and it was published last year, 2024, as an official version, the version 1.0. And it's an XML-based, machine-readable and human-readable format. So what I mean about it, you have seen it at ACCA as well. If you know how to read it, you can, but it's mostly machine-readable. What are the opportunities with IDS? What can you do with it? For the first part, there's the automatic import into software. All the requirements which are in the IDS file can be automatically imported in Archicad or other CAD softwares as well. Archicad has implemented also last year in the version 28 the IDS import. What's also good about IDS, you can, if you import it the correct way, the requirements and fill the values out, you can also do a correct export, IFC export. So your IFC files will be much better than before. So you can ensure the quality. And the third part about IDS, you can do a really easy check. Solibri has the possibility to, you can just take the IDS file per drag and drop, put it inside Solibri, and you have your IDS check, and you know where are some values missing or whole property sets. As a conclusion, from our experience with this Prise project, we want to mention that it was very good that there have been openBIM formats chosen, and everyone should embrace them. Yeah? The second one, we should prioritize the standard IFC properties. Don't sorry.
Overcomplicate.
Don't overcomplicate it. Keep it short and simple and easy. Don't use too much properties which are just for this use case. Yeah? Offer advantages. Thomas told you about in the opportunities. If this project ensures that it adds value, it will be chosen. Yeah? So it needs to be a valuable process. So, thank you very much, and focus on the great idea of building. If you have any questions, you can, we can answer them right now. I don't know if we have time, or you can find us at the stand in the first floor.
I would say we find you at the stand in the first floor.
Okay, yeah. Thank you.
Okay.
Thank you.
Sorry, we're a little bit late, so and everyone, I think, wants to go to dinner too. But they like to answer questions. They did it very well also at our university. What you will see now is that we make it a journey. Thanks a lot, Thomas and Matthias. Yeah. What you will see now is that we make a big journey. It's like 7 talks through 6 different countries. And now we start in the Far East, and we'll hear something about Singapore. So let's come to stage, Sami Mikkonen, for automating accessibility compliance in building design. Thanks a lot.
Did I tick? Yes, it's like a team meeting. Am I audible? Am I present? Hey, good to be in this warm, sunny Vienna. We're from Finland, and we don't have a sun, so that is really good to see some sunlight. I'm Sami, CTO in Solibri, responsible on doing technical stuff and responsible on our product development. And if someone asked from our marketing department, I went through this slide really precisely. What to remember from this slide is that we have 100 passionate persons who wants to do better builds, and then let's go to the actual content. We have been now working together with Singapore BCA agency and also with our partner in Singapore called ASPLP. And this fits really well on our mission about the better builds. And what we have now done in the last 6 months is really focusing on accessibility. And put on Google BCA COIA 2025, you will get that book. Read that. It's awesome. It's one of the best, let's say, authoritative written thingies what we should follow. It really improves inclusiveness and also it's understandable. It's been written by human an AEC specialist. So it's a great book. So what we have done is, on the final page of the book, is 2 solutions. One, Solibri extension, which covers approximately 83 regulation requirements from the accessibility in the Singapore. And we also did this kind of a web checker for the industry to be able to use. We have been building 25 years on BIM coordination tools, which has lots of buttons. This has less. And it supports open building smart standards. How did we get on those 2 tools? And this is really a dangerous slide for me. I can spend really much time on this one. So if you have any questions on these slides, go to Pianitz. She has been creating the things with this one. The analyzing part. We didn't have time to do any kind of LLMs. We had PIA. So what we did, we convert the requirements on this kind of 4 different buckets. One, not gonna happen with the machine. Then those ones which will take a lot of time for us to develop. And BCA was kind enough to say that, hey, you have 6 months time to deliver something. So we kind of skipped those ones where we didn't have algorithm background ready. So, and then we also validated, does the requirement have 0s and 1s, or does it have kind of a requirement what we could convert into CAD guidelines? And that we did. So eventually what happened was that then we did the IFC mappings. One particular nuances on the Singaporean point of view is that they have been with the BIM journey a long time. They have this IFC SG property sets, and they are really liking it, and we had to adapt, so we needed to use quite much IFC custom properties in there. Then we did the IFC mappings, definitions, testing, and we used our Solibri Office as our test bench. So what we didn't have any kind of other rule development platform than what we have already in the Solibri Office, were mostly being used by the BIM coordinators. So in the Solibri Office, we created the Singaporean governmental rule sets, and we deployed those in a cloud environment. Simple as that, nothing fancy. Same thing, much easier, verify, test, deploy, and redo it. Pia made a couple rounds of that one with our local consultants. So how did it end up? A huge list of requirements of things. This has been divided into chapters. The new accessibility code on Singapore 2025 has, instead of a component listing, it has a use cases. It starts for recognizing the building types and also the space types. In Singapore, it's kind of a small area, but they have a tall houses, what we don't have in Finland. So there is multi-purposes in the house. You might have a school, shopping mall, residential building, and a factory, perhaps in the same building. So we need to do quite much understanding what does this model serve. And that is basically happening in the chapter 2. Then what comes on the cool stuff is the second chapter, the number 3, is arriving into the building. How is that accessible? Then the accessibility will be checked outside of the building and inside of the building, that everything fits. So quite a lot of geometric validations there. You can also see the Solibri rule templates there. And then we are going on the chapter 5, which is sanitary provisioning in the building, family-friendly living, and then we have different kind of requirements for different building types. So basically requirements are repeating. And what happened on the one that we needed to adapt on the IFC SG properties and also following the IFC4 standard structures. What we are reporting on the web checker is BCF, PDF and JSON format. The JSON is kind of a machine readable thingy, not that much human readable, same as actually the IDS XML, but let's not argue on that one. Then we have a bunch of gatekeepers to make sure that we will hit into the right purpose. The space will be available. For example, if you have accessible toilet in somewhere in the 29th floor, we need to be able to check that the route from the main entrance or arriving from the building is all the way accessible. That is basically what we have done for the last 6 months. That made it us to create 5 new rule templates. We will have most probably tomorrow a release where those comes public, so we can reuse the same templates in other places in the world. The main thing what we have added there is horizontal maneuvering spaces and objects, so it's quite interesting what is there. So if you want to know more about what the templates can do, there is Paul Linder. He will tell the nuances on that one, but please reserve a time on that one. Then on the IT side, we have taken on this API first point of view, and everything is available through the APIs. So the check on the box number 4, that is our checking service, which we have put on a container and in Singapore. And how does the web checker look? It's a drag and drop files. It does the model federations. Users are creating the checks, executing it. This is the JSON traffic light respond, how the BCF can be illustrated, and the users can download a PDF report and BCF and start utilizing those on their authoring tools or their CDs or other places where the BCF is available. What happens next? We are discussing how can we do the next steps out of it. We can do the manual checking. This is from Cloud Permit for Finland, automated checking, the hybrid checking, and now we are being in a public for a week, and now we have a 6 months period. If you want to test this, we have created this kind of model health on the web checker. The QR code is there. You need an IFC file, so registered, send the link on your iPad or PC, and you can play around how simplified BIM can be done with Solibri. Questions?
So, thank you. We could take one question. That was a quick one.
Impressive work for the rule set from Singapore. Do you think that will be maybe published in public, that we can maybe have a look to maybe adapt it to the Dutch context, or because probably the checks are the same, but maybe the measurement is different? Or do you think that Singapore will share it, or can you share it, or how that does that?
The book is totally public. Read it. And most of the chapters from 3 to 7, we can replicate it in other countries. It's just a parameter change. How complicated that is.
So thank you. Thank you, Sami, for your presentation. Now, going from the Finnish-supported Singapore, a little bit far west, we come to the Ukraine, and Andrei will tell us about the digital building permits in the Ukraine.
Good afternoon. I would first like to thank the organizing committee and the university hosting us for inviting me and my colleagues from Ukraine to present where we stand in Ukraine on the digital building permits, and we do it slightly different than, well, we chose a different path. We check first project and cost documentation, and then we'll follow whatever you're doing. So we give us a bit more time to follow up on you so that you can advance even further and we can be quicker in coping. My name is Andrzej Podobny. I'm a German national who lives and works in Ukraine. I advise public authorities, the Ministry for Development, on digitalization, BIM-related projects. So I'm the co-author and organizer of the BIM National Roadmap. I'm the lead of the Digital Permit project. We only have a few minutes, so I'll be very brief. I guess you read a lot about Ukraine in the news. Not sure everybody knows this report. It comes out once a year. The next one will be in February. It states, unfortunately, that Ukraine needs some $524 billion in restoration needs. Out of those, $281 billion go to 5 sectors, which is housing, the common topic that we all face. We have it for different reasons. Housing, transport infrastructure, energy infrastructure, education and health. And we all know that the cost will be bigger in the next report. The problem with that is that all those require permitting. It's not a problem, it's just a fact. That means in Ukraine, everything that is as a cost more than $25,000 needs the permitting, and they need it twice for the building and for it being taken in usage. And that means for public and donor projects, they have to undergo a cost verification and a design document verification. And obviously, if we automate those processes, that'd be really helpful. Then the as-is situation. We have, these are official statistics. I believe the real numbers might be lower than the ones that we have registered on our e-construction platform. That means we have some 10,000 architects and engineers. That's the roundabout what we believe we actually have. We have some supervising experts, and we have less than 200 employees of the State Inspection for Architecture and Urban Planning. That's we have the chairman here today. I will introduce him a bit later. That basically have to do all. Well, they issue the permitting. We have an e-construction platform, but they still have to approve it as a human base. And we have 200 persons. That includes drivers, whatever office, and they have to approve all projects twice. All right, you all know this system. This is the BIM-based system of e-construction platforms. Ukraine will be, from a BIM perspective, we're on the level 2. We have our level 1, basically. We have a national e-construction platform similar to Estonia, not as deep, but wide. We have all infrastructure objects, even military, everything is included there, but not everything is obviously online or visible to everybody. The difference is in Ukraine, we have machine-readable cost documentation. We don't have machine-readable project documentation. So, and if you look at it, Ukraine is also, the system is very different to what we've been hearing so far. As of 2012, Ukraine abolished municipalities as being the ones giving out permitting or doing the compliance checks. They are now done by, that's an anti-corruption measure, they are now done by private companies that get a license by the ministry. This way, no one authority can say, if you give me money, then I'll get you the approval. You can go to any company that has a license. So there are 149 companies registered in Ukraine for that purpose. If you look at, let's say, housing in Ukraine, you need some, depending on the materials you use and the design you're using, you need some 80 to 23 books that you submit currently to the compliance expertise checks, and they are submitted in PDF except for the book on cost, which is a machine-readable format. And you can see the directions where they are, and the cost estimates for public projects and donor projects will be the same. This is, as I said, this is the one we focus on because it's machine readable. And obviously the goal is to verify, the next one is to make a validation whether the quantities included in the cost documentation correspond to the quantities included in the project documentation. So in an ideal world, we all know that an architect and the project a design office, they will have a BIM file, an IFC or whatever, and from this BIM file they will extract the quantities into a cost software, and there they build the cost estimation file. So this is how it should be, but from a perspective of the controlling authority, you don't know whether they did that or they come up with different documents. So obviously the goal is then to check both files on whether the quantities are the same. So we did a project, it was funded by USAID. That should give you an idea of where we are with the project. So we did a look at the world status, Ukraine status, and construction classification systems. Basically, we looked there on United States, UK, and Germany for the cost systems. We looked as a Ukrainian construction elements classifier. It's a classifier needed to combine to actually make the bridge between cost documentation and project documentation. We looked on all the legal requirements, obviously, for what's needed in the cost expertise, what is supposed to be done manually at this point in time. We checked, we looked at all the cost checks. Obviously, you have an interesting in this situation, what can be the differences in the cost documentation compared to the project documentation? So what kind of deviations would you eventually allow or not allow? And then we looked at what technology is out there in the world. So obviously, we know most of the projects, with everything that's published on Vienna, on Madrid, etc. We reviewed, and we had a look at the cost software, and it's quite clear most BIM software is international, cost software is always almost national. So we have 9 cost software. So whenever a German company wants to do public business in Ukraine, they need to use a Ukrainian software because no German software or no French or Finnish is available to do Ukrainian cost system. I'll keep it brief. Key issues when you look at cost estimates. Let's take this cost estimates are organized by types of work. And design documentation is organized by structural elements. That's why we need the structural elements classifier. So, but basically that means whoever is now checking basically is not able to compare the quantities. That should raise some bells for efficiency-wise and otherwise. The second one is very interesting. The cost documentation we have more in Ukraine at the stage for the permit to start construction. The requirements are much more extensive, more detailed than they are for the design documentation. So, but the question is, how do you then compare one to the other if one is more detailed than the other? Obviously, you see there's error and distortions. You can make errors in the quantities. You can make errors in the prices. And obviously, what we want to avoid is having those. And we want to make sure that when we issue a permit for public and donor projects, that this is consistent with one another. So as is versus to be. Right now, there's a cost estimation file. It is checked against cost norms, which are available on our e-construction platform in Word. It is checked against the contract, the terms of reference in the contract. So the cost expert has to check whether actually it is built or what is agreed in the contract. And obviously, they have to check the project documentation. But you might imagine checking a PDF or 23 PDFs, which are 23 books, versus one machine readable file. That is not so funny. And that's why one of the reasons was a large manual data sets to be checked. And the entire cost estimation process is supposed to be going, the entire permitting process, the compliance review part is supposed to be going not longer than 30 days. With all corrections that may be needed for every of the sections, directions. Okay, that was too quick. The goal is obviously, if the project documentation becomes IFC, that we can be able to measure quantities of materials or works. Prices, we obviously are not contained in the BIM file, but since Ukraine at the same time is building an electronic pricing system, with that system in place, we can then check prices as well. Yeah, that's, how do I put it? That's a political effect of USAID not existing anymore. So the ministry is right now in discussions with, with certain with partners that are engaged in Ukraine. Basically, most European nations are engaged in Ukraine, looking of who has an appetite and considers this is very valuable. So obviously, we'll working on terms of reference. They're almost ready. And then we looked at Madrid, for example, and then we'll hopefully next year start with the developing part of it. The path beyond is obviously we start with comparing the documents, the cost documentation with the project design documentation, but eventually we want to do what everybody else does. checking all other books against the compliance norms, the budget, all other norms that exist. And that's the last thing I want to say. You probably have spoken to a lot of us. We brought a big team with us, 6 persons, the first time. That means we have Alexander and Anastasia. They are from the authority that does, it's a difficult name, it's the State Inspection of Architecture and Urban Planning of Ukraine. So basically they're the ones that issuing all the permits using the e-construction platform, but they're the ones responsible. So, and obviously we are also here to understand how much is practical we can already use to speed up process in Ukraine. So it has a very practical effect. Then we have Olena here. She's a main lawyer for the ministry, setting up policies, everything related to digitalization and BIM. And we have a large team here from our Agency of Restoration. It's a very important agency that obviously does most of the restoration projects. We have our deputy chairman here, that is Roman. He is responsible for digitalization, for digital transformation, and they are making in all Ukrainian ministries. We have a deputy minister for European integration, a deputy minister for digital transformation. We also have a ministry for digital transformation. So digital is the topic in Ukraine. So we have Olena Bonder here. She is from Digital Construction Office, also with the Agency of Restoration, and we have the Irina here, the head of the Department of Digitalization. So we are looking at speeding up and we got a lot of ideas from you already, and we hope that now you know what we are doing, that maybe you come and speak with us as well. So yeah, I'm done.
And you put the right slide, question to answer, so we have time for one question, if there is any.
Excellent, then find us in the bricks.
Yeah.
Or during dinner, thank you.
Thanks, that's very interesting. I'm just curious if in the future you've considered kind of further linking the project information, such as a specification for design and construction, to the actual code rules and products and their compliance to the codes, in addition to kind of that connection of the costs, but also the rules and the applicable product compliance.
I had to rush through it. We start with the cost and the comparison of cost and project documentation, but obviously the goal is eventually to do the entire compliance check. So we try to go as quickly as we can. We learned today about DAISY. We already have Anna in Ukraine in our state architecture inspection. So it's a similar tool. So we'll, Alexander and Anastasia, they head away from here to, they're sitting there, they're heading away from here to the United States, getting more done on artificial intelligence. So our country tries to be, we have the Minister of Digital Transformation, he's also the Vice Prime Minister. So he has the goal of being one of the first countries, number 3 in the world, in introducing artificial intelligence for public services, and basically in all sectors. So we should be doing it. The question is how fast we can go, and we know already that it's not just only about the technology; it's about the people. So we have to take a long way. So I'm not sure that all will be done in a year or 2, but the pain points, and for us it's the budget, and you can imagine why. We need to take care of them first.
Thanks a lot. So thank you again for your presentation. And we go one step west, again back to Finland. And Ilkka will present something about the Finland's new Building Act, from pilots to practice.
Thank you. First few words about Cloud Permit. Company that is focusing solely on permitting in built environment. We operate in Finland, where we originate from. We also operate in Canada and in the US. So we offer services for over 1,000 municipalities. And just to mention, in Finland there are 300 municipalities and 245 are using our services for building permitting. Today I'm going to talk about how did we implement BIM-based permitting in Finland, how did we pilot that, and then also some words about the legislation changes in Finland. So how did we get there? Over the years there has been many milestones and projects just to get where we are today. And a lot of has happened outside of Cloud Permit and our services, obviously. So logically, I will start in the middle from Kiradici project. That was a project of our government-funded project for small trial projects. Like we give you 20,000 euros so that you can try your technology. There was about 10 different projects related to building permitting, and we were participating in 4 of those. The next big one was, maybe the most important project was Rava 3 Pro, 3-year project also funded by the government, run by the municipalities, 23 municipalities, and that was a project where a lot of the tools were created that were required by the upcoming or the coming law, and also a lot of national standardization was made there, and also the checking rules to check against the new legislation and the standards. Then we also participated in EU so that we could see that how this all fits into the European scale, what do we have to take into account in our architecture and so forth. Yeah, from there, I think what did we do in standardization in Finland? So obviously the Rava 3 Pro was the key to give us the standards so that we could use the tools and the industry could provide us the IFC files that are required for permitting. Of course, the law changes a little bit just before it got into force. So now there is a Rava 3.5 and Rava 4 coming. But right now we are working with the Rava 3 Pro requirements. What happened on the legislation side? The preparation started after the trials, and beginning of this year we had a new building act, but the BIM part will be in force beginning of next year, and also we'll have a new decree. System side, our digital permitting platform was introduced in 2013, started also as a pilot. We had our BIM features, first features 2022 with the submission, and this pilot that we are now talking about was from the end of last year until the beginning of this year. So that's where we are focusing today. So it's just a tiny piece in this whole road. And the Ryhty repository, what you can see also, it's a government project. They're building one kind of digital building logbook for Finland. So everything that's created in the processes will be delivered to the central government repository. Okay, something about the legislation. So the new Building Act, it actually defines a couple of important things. First of all, what is BIM? It gives a legal definition for BIM in Finland. Then it also tells that, okay, you can use BIM in your building application, and the municipalities have to be able to process the BIM. But it gives the option to the applicants to decide whether it's the BIM-based or then it's other machine-readable format. So, the machine-readable format is then defined in more detail in the decree. Yes, and the Building Act also defines the delivery to the national repository. So in the decree, there is more details about what is the information that needs to be in the models, so that it's considered as good for the permitting process. And of course, we have our national building regulations. Those didn't change when the Act changes, so those remained. It means that how you build in Finland. Then we had the national standards from the data requirements in the decree. And also for the users, for the applicants, for the industry and for the authorities, a lot of specifications and BIM guidelines have been made. These are the tools that we created to comply with the law. So first, top left corner, we have the BIM submission. So you can submit different versions for your permit models, for your building site models, for your special plans, and also for your as-built models. Bottom left, we have the IFC viewers. You can see everything in 3D. This is a very important benefit from BIM, using BIM, so that everybody in the project can see what this really means, and they don't have to watch the 2D presentation of the same things. We also have city model viewer integrated, so we can always see the IFC in the city model. And the technology that we use there is SOVA 3D. By the way, the technology in our viewer is XeoKit, open source tool. We use, for the data, we use openBIM standards, IFC, BCF, and IDS, obviously. The bottom right corner is our archiving, so everything that is used in a process needs to be permanently archived according to the law. So we have the tools to do that as well. Pilot focused on the automatic checking. So this is the view that is given to all the users. And when you upload a model, then it does the checking automatically. So this is what we did in piloting. We were trying to find the gaps. We were trying to improve, increase the competence in the industry, in the municipalities specifically. And yes, we did find the gaps, and yes, we tried to improve the competence, but we also made a lot of findings that the process, or people don't know how to use the process, how the process works, and so on. The main thing about the piloting was that it was done together with the tool providers, with the tool providers, with the municipalities, with the ministry and municipality association who were invited and participating, but not officially members. So it's a joint effort. And just to end my presentation with some numbers. So it's not only 3 or 4 models that have been submitted in Finland. Altogether, we have in Lupapiste 716 BIM models, and with these pilot municipalities, 378. So there is a lot of experience, even though there hasn't been the mandate yet. The mandate comes next year, but the industry is willing to use and test the new tools and new processes. And here we can see how the number of BIM has been grown over the years. And as we can see, because there is no motivation, there's no mandate, the motivation is you have to be cost efficient, it has to be cheaper, it has to be quick, and it has to be easy to use. So that's where we are focusing with the municipalities. Thank you.
So Ilkka, thank you. Very impressive numbers. So is there any question? So if not, thank you again. And now we come a little bit more west, back to Germany. They stole the motto of the Three Musketeers and used it one-fold, and Ronnie and Andreas will present how the state is now with this one-fold system in Germany.
Very happy to participate here in this little family reunion of digital building permit worldwide. 200 experts. First question to you. Raise your hands. Who participated in the Barcelona meeting 1.5 years ago? Okay, a few. And now second question. Who remembers our presentation about the German digital permit? Okay, very good. So, but we tried to do our best that you remember the next time. And I need the... Yeah. as was heard, the German policymakers had the poetic idea of creating a program which was called Einer für alle, one for all, and all regions should work together for a brighter future, and that's what happened in Germany. One region took the lead, developed a solution, and the other regions could easily join and also use it. And we are very happy that today we have 13 regions that have joined the solutions, and this is very easy for them, software as a service, and so that's the situation today. We have many services in this solution. It's not just one application, there are like 30. All the life cycle is covered here. And also in Germany we have different laws. Every region has a different law, so we have a solution which is flexible. We can react on this, and we have a process which is digital from the beginning to the very end, and this is a big advantage. And we are constantly improving our solution. So if I look back 1.5 years and today, so you really can see the improvements from day to day, and we take small steps but also big steps. I will tell you a little bit about the current situation. Ronnie will tell you about the future. And this is our technology. I'm not going to explain it into big detail, but remember we have a process room, which is an online communication and collaboration platform in the cloud, which combines on the one side the front end for the applicant, so you can write your application, submit it, and on the other side you have the back end for the public authority officer who does all the check, and then they communicate, and then they send the approval, and everything is digital. And on the right side we have connections to other interesting external systems that will bring all the innovation to the system. So the core is ours, it's always the same, but we are very flexible on integrating other topics like BIM, artificial intelligence, and so on. Yeah, and now we have also some numbers. So this is from last month, even 2 days ago I received the new numbers. So we have now 277 municipalities that use our system all over Germany, and now we have about 60,000 applications that have already submitted. So like every month is now like 8,000 applications come in, and we are very proud that we see this positive development, and every month there are new municipalities joining the system and going forward. You can see like July 24, like in April we met in Barcelona, so we were just about to start, and now you can see a constant positive development of municipalities using the system and applications coming in. We also have made a top 10. It's always interesting to see like which municipalities are the best. People like to compare each other, and we see especially Baden-Württemberg, the southern west region in Germany, many people know, so that they also always like to build their own houses. Yeah, so it's for them very popular. And you see, the system is in production, is heavily used. Many applications come in, and it works. So this is for us a good feedback. This is a screenshot from our front end. If you want to see the whole application process from the beginning to the end, come and see me. I can look at my laptop and I can demonstrate it. And also interesting for us are like what is the effect of our solution. And we're talking to our municipalities, and this is one feedback from the municipal district Wittenberg. They are one of the top 10 users, and before they started digital working, they had like 115 days average time before the approval was sent. In the beginning, they were aiming at 90 days, yeah, so a little improvement. But they ended up with 50 days. So I think this is a very good result, which is also shared by other communities. And yeah, why is this? Because yeah, digital communication is much faster. If you have a document which is wrong, you can easily exchange it. The applications, they have a higher quality. They are more flexible. And especially the participation process can go much faster. And this is the main benefit. And yeah, and all these benefits, they are shared among the other municipalities. And we look forward to see more results like this. And now I will hand on to Ronnie. Thank you.
Thank you, Andreas. Give it to me. Last year in Barcelona, I showed you our future plans. I talked about AI, GIS, and BIM and other technologies. And now I will show you some results. The first one is an AI-based case summary. You can see it's only in German available, sorry, but I will explain it. You see the local building authority or a participant, they can choose here the case summary. And in this case, there has a case name, there is an applicant, there's a building site, a status, and so on. And you see very short the main facts and about a case. If you are new in this case, you have there good support. But very more popular is the case AI-based case information. The local authorities, the public official can ask questions like what's the telephone number and who is the applicant is the first question, and the second one, what's the telephone number of the architect, but you can ask also information about the building project, other things. That's the new feature from the December release, and we are very curious about the feedback of our users. And a third result is the BIM checker. It's just an MVP. It's but I will show you. We can upload IFC files, and we have a viewer, and then is a possibility, an option to have an API call to a BIM checker, and then you can see the result. The green results are okay, the red one is a problem issue, and so on. And it's similar to other solutions we saw already today. And yes, AI integration, BIM checking integration, that are our main points. We are still working on the AI integration. We have there also a GIS viewer and so on, but we will do much more in geo-reporting and so on. That's on our list, so to say. And I will give you, yes, only one thing, and then I'm ready. Another feature is a process mining methodology. We have an expert for process events that, so that we can easily use this technology and methodology to mine in this process data models. We had yesterday our presentation to this topic. Thank you very much for your attention. We are ready.
So thank you. Since we're quite ahead, behind in the time, I would say we take these questions then to the dinner or tomorrow. So thanks a lot, Ronnie and Andreas, for your presentation.
Thank you.
Thank you.
So now we're coming to a presentation which we all want, embracing the digital shift and going to Catalonia, so the furthest west we go in this session. And thanks to Natalie and Christina for their presentation.
Thank you. Thank you. Good afternoon. We are Natalia. I'm Christina from the government of Catalonia. Thank you very much for being here at that time. You are really brave, so thank you. We would like to explain about our office. We are from the business management office in the government of Catalonia, and this office aims is to help enterprise to open faster and easier in order to open the business they need. depending on the activity of this business, the procedures or the permits they need to obtain are more simpler or more complex. Why? Because if the activity they want to do have a lot of impact into the environment or into the health or safety of citizens, then the procedure is more complicated. So we already have done the digital shift in the simplest and medium procedures. And now we are trying to do the digital shift into the complex world of the digital permits. And let me do a spoiler at that moment. We are not going to talk about building permits. I'm sorry, DVP committee, but about activity permits. Why? Let me explain about that. We have been in touch with other partners from other countries, and it's because of that we obtained an Interreg project with other partners in order to implement the BIM into these complex procedures. Why? Because in the simpler, the methodology is different. To do the digital shift is different methodology that we can use when the procedure is very complicated. Okay, so it's because of that we have seen what the others in the other countries are doing. And we have obtained this financing project from Interreg with other partners as the city of Tallinn, that Christoph is here, so hello Christoph, and other partners. So we are developing this BIM for GOP project, and we have a financing of 1.3 million euros to exchange good experiences and knowledge between us, and then in the core phase, and then we have another year to do the follow-up phase and to implement the digital shift. So looking what are doing the other people around the Europe, we have found the BIM models. And first of all, let me define what we understand by complex procedures. What is a complex procedure for us? It's a procedure that can be communicated only. It needs a permit. This procedure needs that the administration evaluates some documentation and give an answer to the business or the promoter. Okay, so it requires this information, and in addition of the responsible unit of this procedure, these complex permits need also other stakeholders, other partners to give some assessment or whatever. So it's a lot of people involved in obtaining that permit. Even can be collegiate bodies, not only individual person, but collegiate bodies. So it's very complicated. Sorry. No. Okay, and also it's necessary to provide public hearings and information to other bodies and other units, etc. And also that the information that the stakeholders need to assess, to review, is changing. It's a lot of documentation, so it's very complicated to give the resolution of this permit. So with the actual or the traditional procedure, it's very long time we need to finish these procedures. Almost 3 years, can you imagine? An enterprise who has invested, has put money in doing some works and everything, has to wait 3 years. It's terrible. So it's because of that, we can also, it's very difficult also to reuse data in order to do inspection or other phases of the project, because this data is not in an interoperable way. They are in PDFs, so it's not possible to reuse all this information that the complex project has. So we want to work in data-driven project in order to reuse that data, automatize, etc. So the thing is, what kind of complex procedures we have in Catalonia? We have the building permits. All of you have been talking about that. These building permits can be about territorial also planning, that not a lot of you have been talking about planning, but I'm sure it's possible also to use BIM in that. And then the building, yes. But also we have the activity permits. And we think that we also can use the BIM model, BIM model, for these activity permits into the environmental scope. We have different permits in that aim. And also we have other sectoral permits that are like an hybrid way of, some part of them are like building permits, but all other part are activity permits. We need both of them, so they are even more complicated. Like the renewable energy authorization, in that kind of permits is very complicated to obtain because they are a mix. Okay, so Natalia is going to explain our, sorry.
Thank you. Now I will explain you about what is the pilot that we are working on now and some details related to this pilot. Now here you will find the different tasks that we are working on in this pilot. No? One is because we need to build all of this data model that we need to for this procedure. The development of databases, project templates for all of this business that they need to provide them, and all of the use of GIS information, etc., that we are using in this pilot. But here, only to put the focus on in some of parts of that is the legal, to guarantee all of the legal, because here the complex is not only to put the IT solution, is that we need to guarantee all of the legal procedure and to change the mind all of these kind of unit people who is working in these units, and they are not thinking in BIM and what they are doing with BIM. No? And it's for that, for example, a lot of you were talking about the GIS, but if you want to increase, if we want to put a procedure here, it's more important to freeze when business when business register the procedure, is more important to freeze the situation and to freeze the GIS lawyers that we are using for this procedure. Because Christina said you that this process, the time frame that we need to evaluate this procedure is not very short. And it's for that we need to traceability all of this information, all of these tasks, all of these validations in all of the part of the process. And not change the requirements during this time that we are using this validation. And it's for that yes, during this process, during this pilot, we need to guarantee all of this sufficiency, because in this procedure, the unit responsible and all of the stakeholders, vectorial stakeholders that they are participating in that, they need to evaluate all of this information. But some of them, many of them, they don't need to evaluate all of the information. And it's for that it's more important that these IT solutions offers the options that to offers view, sectoral view for them, to remark some information and not to put all of the information, all of the building information and elements, because it's important to remark, because they are not, they don't have this framework in the daily work, and it's for that to work in that and to think in that. For them is important to, yes, now they do a lot of reports to reclaim new information, etc. And it's for that BIM helps in that. But in this procedure, it's more important to include this public information, because we think for the citizens and the society is more interesting BIM in that, because here we can use to guarantee this public information. And after, in this procedure, we included other thing more, no? That is not only that I need to evaluate your data, is that I want to put a limited information, or maximums parameters in your project. And BIM needs to guarantee that. It's for that you know that BIM has all of this possibility, offers these possibilities, but it's for that now our big goal is to accompany all of these kind of units, is accompany all of these legal stakeholders that is working with us to concrete and to work in that. And it's for that I think that the big goal is to increase these BIM club funds in this way, to include it, because we are here, but at the same time that we are here, our legal colleagues are working in reports. No, they are working to create a new legal frameworks, and it's for that we need to change this mind of all of them.
Yes, in fact, we need that, just advance. The problem is the challenge is the management, the change management, because they don't believe, they are not BIM believers, and we need more BIM believers. So I suggest to the DBP committee that next year you can call not DBP committee, but DBP, an activity permits conference or seminar, because they came here, because when we have told to our colleagues from the environment department, said, come on with us and now you can see, and that, they say, no, because it's about the digital permit conference. We are going when the activity is included in this conference. So it's because of that I suggest that to the DVP committee. Thank you very much, and thank you.
So, thank you, Natalie, and thank you again for your presentation. We also will put the questions to the dinner. Thanks a lot. Now, after this journey through 6 different countries, we are coming back to Germany, to the nice city of Cologne. And Jörg has now heard so much that he's also trying to embrace this digital shift and likes the new processes and new services, but ask a question which a lot of architects are asking.
No? Yes. Good evening, everybody. To have the penultimate lecture of the evening just is a new threat for me, because according to my opinion, everything is already said, but not by everybody. So as far as I got the feeling that I will be the first practicing architect to be on stage today, so I will get into the adventure and change my lecture a little bit, the focus of my lecture. So my talk will be little bit bumpy perhaps, but anyway I will use these old slides as well. So. Yes, just why am I here? We are taking part in a state-funded project that will implement digital permits in North Rhine-Westphalia, which is on the west side of Germany. And yesterday evening, André Fontron already showed you or presented you his software, which is called the BIM permit software. So we are part of this program, and we said yes, we would like to take part in this program because we thought there is a very intelligent way of solving the problem with the digital process. So. Before I start, just to give you a short. Once again. Here I am. I wanted to give you just a very short overview of our office. So we are 120 20 architects and urban planners, mostly based in Cologne. We have 30 years experience, and the focus of our work is as well urban design as architecture, buildings in the healthcare area. We do also housing and offices, and also strategic planning, where you have to deal with a lot of people, with a lot of stakeholders, is one of our expertise. So the building that I will talk to you, or which is the reason why we are in this program, is an office building based near the central station of Cologne. And we tried with our client to give an input and to help to get the whole process running, especially the process with the Cologne department of building department. So the process is, after this day, is not as innovative as I thought, because a lot of systems all about Europe or all about the world we heard today are doing more or less the same. That means you have the architect makes his model. He puts it into a cloud-based software. Tests it, gets a report, has to refigure his model until everything is checked, and then he delivers the model together with a checking report. It's a qualified checking report in this case to the community, and they have not to check 100% of the project. They only have to check, well, let's say about 30% of the project, because all other rules have already been obeyed, and which is presented by the qualified report. And in the end, if you're lucky, you will get your building, you will get the permit. So one thing I anyway would like to point out is that a fundamental requirement for the obtaining a building permit is a good modeling guideline. You get this guideline either by the software or by the building authority. And it has a lot of things that should be provided, especially how the building is, how the model should be modeled, which kind of classification and attributes are required, the structure of the model itself, the LOEN or LOIN level should be also be documented, and then the required exchange format, which is mostly IFC we heard today. So it's not well. You have to mention that it is really a task for architects to fill all these requirements of the model. You have to have employees that are well educated, who know how to use the software, because the quality of the model is really crucial in these processes. And this is one thing you have to have the right employees, and these employees will not be the cheapest one, how to say, the ones with a low paying. But what I would like to mention a little bit more is that in our philosophy or in our expertise, we felt that there is a shift of efforts from the authority to the architect, and that is that we are already trying to solve, let's say, 70% of the building rules before we submit. And this has not only to do with Verantwortung. Sorry, I'm just hanging. Responsibility. Thank you. You also overtake more responsibility that you usually do as an architect. So there is more work, more responsibility, and sorry, I have to ask, shouldn't there be more fee for the architects? Yes, Christian says yes, because yeah, more work means more effort, means more need for better paying, and I think this should, especially when you mirror the day to day, we are not so far away from these kind of processes. So I'm also a committee of the architectural chamber in Germany, and I will go home and go to my chamber colleagues and say we have to look to give our architects in Germany an idea what will be their next challenge. So yeah, I learned a lot today. So we heard a lot about this cost and time benefits. I don't have to say, and yeah, all of these conclusions have been told today a lot of times. Just keep in mind that architects will have a new role and will deliver new services and perhaps should get more money. So that's my story for today.
So Jörg, thanks a lot for your presentation. And we started this session, so once again, thank you. We started these sessions with 2 Austrians, and we're gonna finish it with 2 Austrian. You already have met Daniel, and now he's joined by one of my colleagues, Leo Geishofer, who will present about evaluation of a checking software. So everything we need for speeding up the process.
Good afternoon, everybody. Welcome back. My name is Daniel Pfeiffer, and this is my colleague Leo Geishofer. And together we are working at the research department for digital building processes here at TU Wien. In the last 2 days, we heard a lot about future research and tools, so basically what could be possible in the future. But today, we want to talk about what is possible today, about checking softwares. As one of our key speakers, Roman Schneider, has already mentioned today, authorities are in need of criteria and in need of comparison of different checking tools. So, but let's not get ahead of ourselves. Let's start at the beginning and give you a quick overview of the digital building process as we imagine it. First of all, everything starts with a project idea. After that comes the creation and the checking of the survey plan. And then an optional step, the pre-check of the building application model, the BIM. And after that, the digital openBIM submission and checking process. If everything is according to the law, we can then have the neighbor review and hearing. And if the neighbors are also happy, the authority may issue the building permit. The key takeaway from this is we have 2 steps that majorly depend on a checking software. So you could say it's basically the core. And in a research project not long ago, it's called Breeze Vienna, we used Solibri. And we found that Solibri does a lot of things great, but it still isn't fully suitable for all the authority needs. Then we checked internationally, and we found that there are a lot of custom-built solutions, but we didn't find any comparison in the name of a digital building permit of checking software. So we wanted to bridge this gap, and we started with an elicitation of requirements. Our approach included expert interviews and workshops with Vienna's building authority, and iteratively we refined all the requirements and created a set of criteria. It became clear very quickly that the authority has specific needs, and next to open standards and long-term reproducibility and adaptability, we also found that the scope is way different of this than of a normal model checker. Next to the classic model checking, they need a whole system of rule management, and ideally everything should be changeable without programming skills. So we took all the criteria we found and put them into two different sets. The knockout criteria, as the name states, must be fulfilled, otherwise every software is excluded. And score criteria that makes it possible so that we can have a comparison between the softwares. From now, Leo takes over.
Let's get started with the checking process. First, we checked whether the KO criteria were met. After this step, these 11 applications remained. In the next step, we checked whether the score criteria were fulfilled, given 10 points, given points from 0 to 10, according to a strict predefined schema. The needed information came from official documentation, developer consultation, and for the most part, hands-on testing. As Daniel mentioned, each score criteria has an assigned relevance, which is used for the calculation of the total score. Considering this, model checks account for 37% of the total score. This highlights that the building authority's requirements are widespread and go further than just model checking. The available model checks are part of the scope of checking. The general criteria are related to topics like long-term usability and efficiency. Licensing and costs should be clear. Now let's get into more technical details. The typical collision, distance, and property checks are part of almost every checking software. I mean, that's what they're developed for. Still, there were several issues in the openBIM use case. For example, the Pérez concept relies on custom property sets. But some of the applications simply do not support, only support the official building smart property sets. Problems were also seen when it was necessary to test multiple models at once. Larger differences were seen in regulatory checks. To clarify, regulatory checks are more complex, legally based checks. For example, the escape route analysis or the determination of light entry areas. Solibri Office offers a solid set of rule templates for regulatory checks. But that is not necessary, as long as the scope for checking can be expanded, either through an API or visual programming. It's worth noting that some applications could not be expanded by the users at all. Differences were also seen in their deployment model. 8 were locally installed and 3 were web-based. For web-based solutions, self-hosting is essential, as the data cannot be handed to third parties. The availability of the source code is also of great importance for the long-term usability. In fact, only Bonsai is fully open source. Still, the source code for Nexus Twin can be purchased. Another key aspect is efficiency. Vienna's legal requirements are extensive, meaning there will be hundreds of checking rules. However, with 5 of the 11 examined applications, each rule has to be run separately. This is one of the reasons why automation can be crucial. Let's get to the results and take a look at the 3 applications that best fulfilled the building authority's requirements. BIM Permit reached a score of 6.8, followed by Solibri Office with 6.7 and Bonsai with 5.9 points. BIM Permit is a web-based solution focused on checks using a no-code approach with visual programming and IDS. Bonsai, Bonsai, on the other hand, is locally installed and honestly currently quite limited in its checking capabilities, but offers several advantages coming from its open source nature. Solibri Office is also locally installed and offers a collection of roughly 50 rule templates. Nexus Twin ranked 4th, but one feature deserves special attention. It is a web platform separated in 2 separate areas for rule set development and model checking. The key advantage is that admins can assign roles to users, meaning there can be different users for the rule set development and model checking, while ensuring that they are both always working with up-to-date rules. Now, the highest ranked software, BIM Permit, reached a score of 6.8. Keep in mind that Solibri Office has 6.7 points and did not perform with satisfaction in the Prise Vienna use case. Does this mean that the criteria were based on wishful thinking? Possibly. This is why further validation with building authorities apart from Vienna is necessary. If the criteria remain applicable, we can conclude that the building authorities' requirements are simply way more complex and specific than those of, for example, a planner. Based on these results, a building authority may choose between 2 pathways. For once, find compromises and decide whether one of the existing solutions is a suitable match. Or develop their own solution, either based on an existing one or starting from scratch all over. In the end, that's the building authority's decision. I would have loved to go into more details. If you feel the same, my thesis will be published in January, or ask your questions right now. Thank you.
So thank you, Leo and Daniel, for the presentation. Leo, I'm not sure if you want to change your thesis now to English, because I think it's in German right now. So for everyone to read it, it should be in English. You have to do some work, I guess.
It's going to be done in a few days.
Yeah. So thanks, everyone. This was the 25th presentation of today. So we had quite a big program. And now we are coming to the closing remarks, the conclusions, and also an outlook. And I end the presentation of the awards, and therefore ask Judith and Simon on the stage.
Thank you, Christian. Yeah, we are at the end of our second day, and we want to use this last session to celebrate the great contributions we had the last 2 days, and also to look a little bit into the future. So yeah, let's get right into the awards. Our awards were organized by Jose Granja, who unfortunately could not attend here, so Judith and I will present the awards on his behalf. Let's get started with the Best Paper Award. The Best Paper Award decision was made by the review score at first, and then we had a small committee to decide on the best paper. And I would like to invite the authors of the best paper, all of the authors that are present, to come up on the stage, get their certificate, and we make a quick photo. Yeah, so the best paper of this year's Digital Building Permit conference goes to... too far away. That was planned? Personalized workflows for building permit applications. Thank you very much. Next on, we have a special mention for an integrated LLM-BIM semantic geometric framework for automated building code compliance. Unfortunately, the authors are not here today, so we will send them their special mention. Now I'm struggling. Can you help me? Thanks. Well, and then we have a Best Poster Award. Thank you for all of you who voted for the Best Poster. The voting closed today somewhere at 2 o'clock. And yeah, we have a winner. Let's have a look. Oh, it's pre-consultation as the missing link in the Estonian digital building permitting. Thank you very much. Yeah, so that's it with our contributions. And now I want to hand over to Judith to talk a little bit about what's coming next.
Yeah, thank you, Simon. I think everybody knows that my voice is not working that well anymore, but I wouldn't miss the chance to announce where we're going next year. And as you can see here, so I want to invite you all to Munich next year at the end of November for the Digital Building Permit Conference 2026. So I have prepared some slides. So this is the venue, so we are hosting it more or less with TUM, but not at the Technical University, but in this nice place here, which is the Oskar von Miller Forum, quite a short distance from TUM. And for a little bit of overview, not sure if you all know Munich, but so here's the train station, here's the Technical University, and here's the Oskar von Miller Forum. So basically this distance is, which I walk quite a lot, so it's about a 20 minutes walk, so it's quite feasible, everything by foot, but of course there's also public transport available. Yeah, the next slide is about the key dates, so let's say the tentative key dates for the conference. So if you are a researcher, so you have more or less 5 months for the abstract to prepare, so please keep that in mind and start maybe on Friday. And we also plan another scientific poster track, so you would have a little bit more time, and of course a practice track, which I think makes this conference very special compared to all the scientific ones. And just as a quick reminder for everyone who may have noticed this already, just a little note. Can we switch further? Thanks. If you know Munich and what's happening in Munich, always the end of November, it's the BIM World Munich, and we are trying to at least timely align this event with the BIM World Munich. So there will be 1 day overlap, but basically it would be worth coming the entire week, maybe arriving on Monday, going to the BIM World on the 24th, and then of course joining us for the rest of the week. My colleagues, we have a local team already at the TUM working on it, including my colleague Stefan over here. You have met him this morning. And you may also notice this name here on the bottom, Robert Aylmore. He is from New Zealand, obviously, but he will spend his sabbatical at TUM next year, and he will be the co-host of the conference, and which we are very excited about. So I hope we will see each other at a dinner, but then also tomorrow, and of course next year in Munich. Thank you.
please stay with us just a few minutes more. I just want to introduce you where to go to find the dinner. It starts at 19:30, so please try to be on time so we don't let our hosts, the city of Vienna, wait. Yeah, here we have a short a map where to go. You also find this on our website, and at the entrance at the Lichtenfelsgasse 2, colleagues of us will be waiting to show you where to go inside the building. Yeah, so that's it for today. If we see each other at the dinner, we're very happy. And yeah, thank you for participating in this day. And now I want to invite all of you to come forward so we can make